So welcome. Just to introduce myself, my name is Anai Correa. I am an associate lecturer at the University of Edinburgh. I'm a carpentry instructor for a couple of years now. I teach data science courses at the master's level, and I have an MSc Digital Media and a PhD in Human-Oriented AI, Data Science, UX Research and Educational Technology. I'm going to be your instructor today. And we also have Anajat with us today. He's going to help you out with any inquiries. I will hand it to him to introduce himself.
Hi, I'm Anajat. I'm a senior lecturer at the School of Data and Sciences at Brack University. I've been involved with the carpentries and many other organizations for this learning-related activities. I'm very excited to be a part of your learning journey. I usually teach data science-related courses in undergraduate and master's level. Let's learn together. Thank you.
Thank you very much. So I have created a couple of ice-breaking activities. So if you could go to the Etherpad, there is a link there. So hopefully, the first thing that you should do if you go to the Carpentry's Etherpad, just click at the top here, and this is your placeholder, let's say. Just type your full name, and then you can introduce yourself. So the corresponding color is your name. And whatever you type, it has the color that it's next to your name. So do you all have access to the collaborative document? Just give me a reaction, or if you have access to the chat, let me know if you have access to the collaborative document or not.
I was just going to say that it seems people were able to test in the chat, so I pasted the link in there. So if they can see the chat, which it seems to me they do, then they should just click on the link.
So it looks like everyone has access to the collaborative document. So what I'd like you to do now is go to the collaborative document and click on the Mentimeter link, this link here. And we will do a short icebreaker activity.
Sorry to interrupt, Danai. I'm not sure if it's just me or everyone. I see only the lower part of the screen, and the remaining part is taken up by captions. Oh no, it's just me. Okay, sorry.
Is it okay now?
Yes, it's okay.
Okay, great. Right, so just hit on the thumbs up if you are on the link and ready to go, and we can. So this is the link here, and this is the code if you need a code to access it. Great, so let's start. So what I like you to do is that just pick an emoji that describes your mood today. This is kind of a short fun activity to kind of break the ice before we start and get to know each other a bit.
Box only allows words, so please type words. The symbols or characters are not allowed.
If you're using your phone, you might be able to actually type any emojis, but if you're joining from your computer, you can just type words. Great. So it looks like everyone is in a good mood today, so that's great. Right, so let's. Very good, excited, that's great. So let's move to the next one. Well, let's see. What I'd like you to do now is kind of join for the next part. This is kind of, it looks like a quiz and it might award points, but there are no wrong answers. These are kind of a couple of questions about your background and what you want to kind of get out of this workshop today. I'll just wait for more people to join. I think we have around 14 people with us. 4 of us are the hosts and instructors. Just wait for a couple of more people to join. Right. So, have you used Python before? Yes, so 6 of you have used Python before, 2 of you haven't. So let's move to the next question. Do you know what data science is? Yes, 6 people said yes, 1 no. Okay, great. So it looks like you have some background already with data science and Python. So let's start by actually introducing the background of this workshop today. So I'll start with the agenda. So today's agenda, we're going to start now at around 20 past 10. And we will wrap up at around 3 o'clock. We're going to have 2 breaks, one at around 11:45, a coffee break, and then another lunch break, kind of a bit longer, 30-minute break at around 1. So we'll try to cover everything up to plotting, and then we're going to wrap up and continue tomorrow. And this is tomorrow's agenda. We're going to go through that in a bit more detail tomorrow. If you have any questions, please use the collaborative document that we shared with you. It looks like everyone has access to it. It's great. Now, a bit about data science for those who are not familiar with it. So data science is kind of the field that studies the kind of gaining insights from data, and we're using techniques like statistical analysis and machine learning and data visualization to gain those insights. So data science is a bit different from statistics because the data part of the data science is increasingly heterogeneous and unstructured. Like you have text, you have images, you have video. So data is not only referred to numerical data, it refers to every type of resource that you can get and you want to analyze. So it might be whatever, it might be images, text, video, and it's usually very, very unstructured. So you learn how to tame those data and analyze them in order to get insights. So as you can see, this is from Sarisa. This is kind of a projection of the volume of data and information that's created, captured, copied, and consumed worldwide. So as you can see, this is data volume in zettabytes. So you can see how this exponentially increased, which is kind of scary if you think about it. We are here, and it is projected to go up to 181 by 2025. Now, about how we kind of tame those data, and in order to get insights from them, we need to organize and clean them. So there is this term called data wrangling, and that refers to as the process of cleaning, transforming, and organizing your raw data into a more structured format in order to analyze them. And this is important because there is this expression called garbage in, garbage out. If your data are not organized and structured and clean, you won't get a very productive information at the end. This is important because data scientists spend around 60% of their time cleaning and organizing their data, around 20% collecting them, 10% on mining the data for patterns, and the 15% of their time they spend on other activities. Now, about Python. Python is an interpreted, object-oriented, high-level programming language, and it's simple it has an easy to learn syntax. It supports modules and packages, which we'll call libraries. And libraries are kind of bundles of code that other people wrote that we can reuse. And it has an extensive standard library. It has very good documentation. You can find online many resources regarding Python. It's also free and open source. It is well documented, and it's easier for novices to pick up than most other languages. Now, it is also one of the most in-demand skills for data scientists, as you can see from this web scraping kind of resource from towards data science. Now, you were asked to download Anaconda in order to participate in this workshop. So Anaconda is a distribution of the Python and R programming languages for scientific computing and aims to simplify package management and deployment. Jupyter Notebook or Jupyter Lab, you can choose whichever you like. I personally prefer Jupyter Notebook, so if you actually downloaded Anaconda, you'll have access to both of them. So the Jupyter Notebook app is a server client application that allows editing and running notebook documents via web browser. The fact that you open Jupyter Notebook on your browser doesn't mean that you are accessing something remotely. In this case today, you're going to access your data locally, but you can use it on a remote server if you like. Right, so let's start then with our data. Let me close this. So today's and tomorrow's workshop is going to be based on the plotting and programming in Python lesson from the Software Carpentries. I'm going to post the link in the collaborative document. So you can have access to it. There you go. And I'm going to paste that right at the top after the data. There you go. So what I would like you to do, so you have, hopefully everyone has access to the collaborative document and the lesson. So let me know if, just use thumbs up or thumbs down, or in the collaborative document, write in the chat if some of you don't have access to it or cannot see it for some reason. So let me know if you have any issues accessing the lesson. Great. Great, so it looks like everyone has access to the lesson. So the next step is for you to download the data that we're going to use today. Which you can find here, the Python novice gapminder data.zip. So what I'd like you to do is download this zip file, and then create a new folder on your desktop and unzip the contents of the data into that folder. You can name your folder whatever you like, Python workshop, something that you will remember and you can easily access, and then unzip the data in that folder. I'll just wait for a couple of minutes for you to do that. If you have any issues, just let us know. Just give me a thumbs up as soon as you've finished doing that. So have you downloaded the data, create a new folder? Just let me know so we can move on to the next bit. So this is an important step because you won't be able to follow the rest of the workshop if you haven't done it. So just let me know if you have, either in the chat here or using the reaction buttons on Teams. Great. So I assume that everyone has done so. So let's move to the next bit, which is running and quitting. So as I mentioned, I prefer using Jupyter notebooks. You might want to use Jupyter Lab. There are many ways of editing and managing code. Some of you might be familiar with Visual Studio Code or other text editors or PyCharm, so some other integrated development environments. We are using Jupyter Notebooks because it kind of offers a really nice environment where you can also add markdown cells and add context to your code. And it's really nice when you want to kind of export your notebook as a report or something like that. Jupyter Lab and Jupyter Notebook have very similar features. You can easily type, edit, and copy, paste blocks of code. Tab Complete allows you to easily access the name of things. It allows you to annotate your code with links and different size text and bullets, etc., to make it more accessible to you and your collaborators, which is what the markdown cells referred to are. It also allows you to display figures next to the code that produces them to tell a complete story of the analysis. So each notebook contains one or more cells that contain code, text, and images. So in order to start with Jupyter Lab or Jupyter Notebook, you can type Anaconda on your search bar. And depending on your machine, it might take a bit to start. So let's see. So it looks like I have a small problem with my Anaconda. So you can type Jupyter Notebook and you can open the app directly. So if you click on Jupyter Notebook, this will open a new tab on your browser. And this tab will look something like that. So let me know if you were able to successfully launch Jupyter Notebook. Yes. Do you have any issues with using Jupyter Notebook? No. Great. So if I were able to open successful Anaconda, this is how the Anaconda Navigator looks like. You can either use Jupyter Lab or Jupyter Notebook. We're going to use Jupyter Notebook today. So the interface, we are going to navigate to the folder that you created, the folder where you stored your data. In my case, this is the one. And we are going to create a new notebook. So go to desktop and the folder where you stored your data. And in the same folder where you have your data, and this is important, on the same folder where you have your data, just click New and Python 3. And that will create a new notebook, a new Jupyter Notebook for you. And I will talk you through the interface. So this is now a new Jupyter Notebook, the one that we're going to use today. You can rename it. Let's rename it Pandas. Data frames. And I will explain what that means. So you can click here and rename your file. As you can see, it has some options here. So under file, you have kind of the standard options that you have on other programs as well. You can create a new notebook. You can open an existing notebook. You can create a copy, save it as something else, rename it, revert to a previous checkpoint. If you want to go back to a different iteration, a previous iteration of your notebook, you can download it and so on. The edit is a bit self-explanatory. You can cut and copy cells, you can delete them, you can merge them, you can move them up and down. In the view, you can, this has to do with kind of attachments or other metadata. We're not going to use that today, but if you want to In the future, if you want to explore that a bit more, you can add metadata to your kind of cells, or you can toggle like the line numbers at the side. It has to do with how things look, basically. Then insert is pretty basic. You can insert a cell above or below your current cell. Under the cell menu, you can run individual cells. You can run and select below, or you can run and insert below. I'm going to add these kind of hotkeys that you can use instead of going to the menu and clicking run cell and below. You can hit Shift and Enter if you're using a Windows computer, and it will do that for you. So if you, let's say, let's type something and then hit Shift and then Enter, then it will run the cell and add a new cell at the right after this one. Now, the kernel is what runs behind your Jupyter Notebook, is where your Python code is executed. It's what exists in the background and executes whatever you type on your cells. So sometimes you might encounter a glitch or something like that, or something might not work as it is supposed to, or you might get an error, and then you want to kind of restart everything from scratch just to have a kind of a clean slate. So in order to do that, if you have like sort of like a logical error, let's say, and you created by mistake a loop that keeps running and running and running and running, you can interrupt the kernel and then you can edit your code, or you can restart your kernel. You can restart and clear all the output, which means that it will restart your kernel and clear everything you have executed. So this does not delete your cells, it just clears the output. The output is kind of what is shown after each cell. Or you might want to restart and run all your cells, which means that it will restart your kernel and run everything from top to bottom. If you have been disconnected, you can reconnect, or you can shut it down completely. And then you have the widgets and help. We're not going to go into too much detail. Then you have these buttons at the bottom. This is for save. This is if you want to insert a cell below. These kind of shortcuts of some of the most commonly used menu options. You can cut selected cells. You can copy selected cells. You can paste them. You can use these arrows to move cells up and down. You can use this button to run your cell, stop, restart your kernel, or restart the kernel and rerun the whole notebook. Is everything clear so far? Do you have any questions? Great. Right, so we have successfully kind of introduced a Jupyter Notebook to you. So let's go at the top here and rename this notebook as variables and assignment. Hit rename. And the objective of this particular chapter of this lesson is to write programs that assign scalar values to variables and perform calculations with those values, and then correctly trace value changes in programs that use scalar assignment. So variables are really important in Python, and they are basically the names that you assign to values. So the variable names, they can only contain letters, digits, and underscore. and we use underscore usually to separate words in long variable names. They are case sensitive, which is really, really important, and they cannot start with a digit. So if you have, for example, let's create a new variable called AIDS, and in order to create a new variable, you need to assign a value on this variable. So let's say AIDS equals 42. We now have this variable called AIDS, and we have assigned a value to it, the value of 42. This is a numerical value. And AIDS and AIDS are two different variables because they are case sensitive. So Python doesn't recognize this and this as the same one because we have a different, we have a capitalization on the second one, so it thinks it's a different variable. Also important is that variables cannot start with a digit. It is always recommended to use meaningful variable names. So you and maybe your collaborators, if you're working with someone else on your analysis on your Python code, can understand what it is and what it means. Some variables that start with a double underscores like this, they have a special meaning in Python, so we won't use that. And as I mentioned, in Python, we use the equal sign to assign the value on the right and the name of the variable on the left. So now we have created a variable, which is the variable AIDS, and then we are going to create a second variable called first underscore name. And then we are going to use there you go. So we're going to use quotes when we want to assign kind of a character to a variable. So the first one is a numerical value that we have assigned to the variable AIDS, and the second one is a kind of textual variable. So it consists of characters. When we use characters, we have to put them in quotes. We are going to talk about it further in a bit. So now we have created these two variables, and if you want to execute this cell, you can hit run. So now these two variables are stored in the kernel, and whenever we use the name of the variable, Python kind of assigned Python associates this variable with a specific value that we have assigned to it. Now, we can use print, if you're familiar with it, in order to display the values. So print is a built-in function in Python that prints things as text. We can call this function by using its name, in this case, print. And then in parentheses, we're gonna say first underscore name, comma, and then in quotes is, so whatever we put in quotes within the print function is printed as text. And then we're gonna use the second variable, years old. There you go. So if you execute this cell, and you can either use Shift Enter or the run button here, you'll get that Ahmed is 42 years old. So you can see that when we use print and the variables, Python will print the values assigned to these variables. Any questions so far? No, great. So print will automatically put a single space between items to separate them and wraps around to a new line at the end. Now, variables must be created before they are used. So if you try to call a variable, which is how we call this action. So if you say print last name, you will get an error, in this case a name error, because the variable last name is not defined, which means that we have not created this variable yet. So Python doesn't really know what it is. When you get error messages, the last line is usually the most informative. In this case, it tells you that you don't have a variable with this name, so I don't know what you're referring to. So every time you get an error, go to the last line, and you'll get the most information out of it. We are going to look at error messages later on in a bit more detail. Now, you should be aware that the order that you execute your cells in your Python code is important in Jupyter Notebook, because Python will remember all the code that you ran previously, and variables persist between cells. So if you define variables lower down and then rerun the cells further up, those defined further down will still be present. So let's do this example. Let's print my val and execute this cell. We get the same error, name my val is not defined. But if we say my val equals 1 and execute this cell, and then go back to the cell above and execute it, you'll see that now it has the value that we have assigned. So the order that you execute your cells is really important in Python. You can, if you have, in order to prevent confusion, you can restart and run all your cells, which clears the interpreter and runs everything from a kind of a clean slate going top to bottom, as we mentioned earlier. In this case, we want to move this cell up so we won't get this error again. So every time we run this kernel, we have the myval variable assigned the value, and then we print it. Do we have any questions so far?
For increasing the font size, so Control plus or zooming in, it helps.
Is this better?
Maybe a bit more. Thanks.
All right. Okay. Do we have any questions so far? Is everything clear? Yeah. Great. Now, since we assigned values to variables, we can use the variables in calculations. So remember that we have created the variable age earlier on, and we have assigned this numerical value to it, the value 42. So if we now kind of reuse our variable and reassign the value to it, for example, age plus 3, and then hit enter, and in a new line use print parentheses quotes age in 3 years, and then after the quote add the comma and then the variable age. If you run this cell, you will get the new value that is assigned to the variable age. So in this case, it's 45. So it was 42. And then we reassigned the value to it, and we said the new age variable is going to be the old age value plus 3. Is that clear? Do you have any questions? So yeah, just be careful when you're using your variables. Sometimes you might want to use them if they're not really important, but if you use them before in other kind of calculation or in other parts of your code, and then you've changed the value that is assigned to it, then you might get some confusion. So just remember that the order that you run things is really important, and be careful when you reassigned a value to an already used variable. Now, you can also use an index to get a single character from a string. In Python, we have 3 types of data. We have strings, we have integers, and we have floats. Strings are basically all the data that are made out of characters, or everything that is within quotes. It is considered by Python as a string. So if you, for example, even if it's numerical, if it is within quotes, it is considered as a string. So 3 and 3 are 2 different types of data for Python. Just remember that. So when you have a string, we usually use text or characters that are in quotes. These are all strings. Integers are whole numbers, and floats are kind of if you have numbers with decimals, for example. So integer floats are numerical data. Strings are characters, basically. Now, the characters, for example, if we create a new variable called atom name and assign the value helium to it. So as I mentioned, if it is within quotes, this is a string. And then use print parentheses atom underscore name. And then in square brackets, and this is important, I will explain what that is and what it does. If you run that, you'll get 8. So if you go back to the lesson here, and you click on variables and assignment, you will see this picture here. So what that does, what is an index? The string AB, it's not the same as the string BA because we have the letters have a different order. We can treat the string as a list of characters, and in Python, each position in the string has a given number as far as Python is concerned. And it does that in order to kind of, keep everything tidy. This number that is attached to its character in your kind of string is called an index. Indices are numbered from 0. So in Python, everything starts from 0. All the indices start from 0, and not from 1. So keep that in mind later on. You can use the positions index in square brackets to get the specific character that corresponds to this position. So in this case, we start from 0, as I mentioned. So H corresponds to 0, E corresponds to index 1, L to index 2, and so on. So when we used the name of the variable followed by a square bracket and the place, the position index number, in this case we use 0, it will return the character that corresponds to this index. In this case, it's 8. Do we have any questions so far? No? So if you play a bit around with it and say, for example, 2, you'll get L. But if you do that, you will get an error because string index is out of range, which means that your string helium only has 1, 2, 3, 4, 5, 6 letters, but because it starts from 0, it goes from 0 to 5 and not 6. So if you put 6, Python will inform you that your string is shorter than the index that you're calling, so you get an error. Is that clear so far? Yes, no? Yeah, I get some thumbs up. That's great. Right. So we have, if you want, so if you use like a square bracket and then the index number, you will get string. But there might be, you might have like some cases where you want a specific part of the word, not only a letter of it. And that is what we call a slice. And we use a slice to get kind of a substring. A substring is kind of a part of your string. A substring can be as short as 1 character, but we usually use a slice when we want to get a bit more. An item in a list is called an element. And whenever we treat a string as if it were a list, the string's elements are its individual characters. Right, if we take a slice with a notation, so we still use the square brackets, but we say start and stop. So think of it like that. We add the index where we want to start our slice, and then we put the index where we want to stop. So it demonstrates in the output the index, the character that exists before the last one that we add here, and I will explain what that means. Start is the integer index of the first element that you want, and stop is the integer index of the element just after the last element that we want. So remember that this is included and this one is excluded. So it will show everything up to this, but not this. So let's delete that. And let's create a new, we'll actually use the same variable called atom name, and let's assign a new value to it. In this case, string, and this string is sodium. And then let's use print atom underscore name, which is the name of our variable. And then in square brackets, let's type 0 and then colon 3. And if you execute that, you get the first 3 letters of this string. So remember, S0 corresponds to S, 1 corresponds to O, and 2 corresponds to D. So you say, I want you to start from 0, from the first index, and go up to the 4th, but do not include the 4th one. Does that make any sense? Do you have any questions regarding that? double check. No questions so far. Great. Now, there is another built-in function. So we introduced print already, but there is another one that we can use. That's called len. So the variable, the built-in function len is used to find the length of a string. For example, let's type print, and then in parentheses len, another parentheses helium. If you execute this cell, you get 6 because it tells you that the length of the string is 6. It consists of 6 characters basically. As we mentioned earlier, Python is case sensitive. Anything that upper and lowercase letters are different. So make sure that when you reuse your variables and you call them later on in your code, you don't have any capitalizations or other differences. That might make sense to you, but doesn't make any sense to Python. It is kind of very common to use lowercase letters at the start of variable names in Python. This is kind of the standard. So we are going to use lowercase letter from now on. And as we mentioned earlier, try to use meaningful variable names. So the reason we do that is because, one, if you collaborate with other people, you want them to understand what your code is about. And the most important person that you are helping is your future self. So when you're visiting your code, if you have a name like that, that doesn't really mean anything, then it will be much difficult to you to kind of understand or remember what it refers to. So try to create meaningful variable names to help you and other people to understand what the program does. Now, let's do a short exercise. So what I'd like you to do is go to the chapter Variables and Assignment on the Python lesson. Or just retype this on your notebook. And what I'd like you to do, and I will explain. So you can add comments by using the hashtag, right? And I will explain later on what that does in more detail. So I'd like you to do this mini exercise. I want you to tell me what is the final value of position in the program below and try to predict the value without running the program and then check if you were correct or not. Okay, let's try and solve this. Does anyone want to kind of tell me what are your observations? Final value for position is left as position value read from initial just before changing initial value to right. Right, let's see. So first we have assigned the value left to our variable initial, and then we said position and initial have the same value, they're equal, right? So and then we said initial is right. If we execute this cell, and say print, and then parentheses, initial, say position, comma initial. You'll see that the variable position has the original value assigned to initial, but the last value assigned to initial is right. So you say, okay, initial has the value left and position has the same value because it equals to initial, but then we reassign the new value to initial. So at the end, initial has the value right. Any questions so far? No? Great. So let's do another short exercise before we move to the next chapter. I want you to kind of tell me what the following program will print. So we have assigned the string carbon to the variable atom name. And what I want you to tell me is atom name square bracket 1:3 is atom name 1:3. Just add it to the chat and try to solve it before you run the cell. Right, so do you have an answer? Let's see in the chat. ARB, AR, AR. AR, great, yes. So yes, the correct answer is AR. So yeah, please remember that all the lists or the indices in Python start from 0. And remember that the first number is the index that is included in the slice, and the last is the index of the character just after the one that we want. So this one is included and this one is excluded. So in this case, it's AR because we have 0, 1, 2, 3. So we only get these two letters. Great. So let's hit File. Let's click on the File menu and let's create a new Python notebook. You can close this one. So you don't have to to click on the Save button because Jupyter Notebook does that automatically. So you can close that and let's create a new notebook. And this new notebook, we are going to rename it as Data Types and Type Conversion. So rename. Great. So in this chapter, we are going to explain the key differences between integers and floating point numbers and the differences between number and character strings. And we're going to use some built-in functions to convert data types from integers to floats to numbers and strings. We briefly touched on this in the previous lesson and in the previous chapter, and we said that every value has a type, every data, every value is a type of data, and every data has a type in Python. So we have 3 types in Python. We have integers. We use this kind of short abbreviation for it in Python that represent positive or negative whole numbers, like 3 or minus 50 and so on. Then we have floating point numbers, which is represented by this in Python, float. And floating point numbers represent real numbers like 3.14 or minus 2.5 and so on. And the last data type that we have in Python are strings, character strings. And we use this kind of abbreviation for it in Python. And it's basically text, it's character data. So you can use either single quotes or double quotes. As long as Python is concerned, that means the same thing. But please be consistent when you're using. I prefer single quotes. You might prefer double quotes, but please use them consistently. So if you start with single quotes, finish with single quotes. And if we start with double quotes, finish with double quotes. Do not start with single and finish with double because that won't work. So this is totally up to you. You can use whichever you find more convenient. We can use the built-in function type if you wonder, if you have a value or you're not sure what type of data this value is, you can use the function type in order to find out what type of value has. You can use it on kind of values, but you can also use it on variables as well. For example, let's use the built-in function print and then the built-in function type. So you can use a function within a function, but you have to use the parentheses. And let's type the number 52. So when you do that, it will print what type of data 52 is. In this case, it is an integer. So it is a whole number. If you said 52.4 and rerun this cell, then you'll see that this value is a float. If you create a new variable called fitness and you assign go back to 52 and rerun this cell. And then let's create a new variable called fitness that equals to quotes average. And then let's print the type of this value that is assigned to this variable. You will see that this the value that is assigned to the variable fitness is a string. Now, the types of data are important because you can control what types of operation you can do with them, or what types of operation can be performed. For example, if you say print and then in parentheses 5 minus 3, because both of them are numerical and both of them are integers in this case, you can use the this operation, so you can detract 3 from 5. But if you say, for example, print and then open parentheses and quotes hello minus the 8s, you will get an error because you cannot use this operation. You cannot detract the 8s from hello. Python does not recognize that, so you cannot use this operation on strings. Now, you can, however, use you can add things to strings, and you can multiply strings, because multiplication is kind of repeated addition, basically. So let's create a new variable called full name that equals to Ahmed, and then use the plus sign. Sorry, after the quotes, use the plus sign, and then just create an empty quote and add a space, and then another quote, walls. If you print the full name, if you print this variable, you will get Ahmed Walls, because you can add different strings in order. So you have Ahmed plus an empty string plus Walls. It will print that as one string. Now, you can also multiply a string. So, for example, let's create a new variable that's called separator, and in quotes, let's add an equal sign, and that is times 10. If you do that and you print the separator, I have a typo here. There you go. You'll get the equal sign 10 times. Now, we mentioned that we can use the built-in function len in order to get the length of strings, because strings have length, but numbers don't have length, because it doesn't really make sense. In this case, if you print the length of full name, which is the variable that we created up here, you'll get that this new string has 11 characters in it. But if you try to do that, does anyone know what's going to happen?
There will be an error?
Yes. So yeah, if you do that, you will get an error, because the object of type integer has no length. There is no point getting the length of a number. Now, you might, for example, you might have some data, and by mistake, let's say that you have the sales for the first quarter of your business, and by mistake, even though you typed numbers, if you're using, for example, Excel, the type of the cell is converted to a character or a text instead of a number. So when you try to analyze that, even though it is a number, as Python is concerned, it is recognized as character. So you might want to convert one thing to another, one data type to another. So you might want to convert the string into an integer or into a float so you can perform operations with it. You cannot, of course, use operations between numbers and strings. It is unsupported. Both of them, they need to be the same data type. Or at least you can perform operations between the integers and floats because they are both numerical, but you cannot do that between integer, floats, and strings. But if you want to convert 2 into an integer, you can do that by typing 1 plus and then int in parentheses 2. And that will convert whatever is in this parentheses and in these quotes into an integer. And vice versa, if you want to convert the integer 1 into a character, you can use the abbreviation for string and then the number that you have plus 2. So when you convert 2 into a number, 1 and 2 is 3, but when you convert 1 into a string, remember that it adds them in order, so you'll get 1 and 2 as a string. So you have 3 because you've performed an operation, and then you have 1, 2 as a string. And yeah, keep in mind that's not the number 12, it's like 1, 2 as a string. Any questions so far? No, that's great. Yeah, as I mentioned, you can mix integers and float freely in operations because they are both numerical. And also variables only change their value when something is assigned to them. If we make one cell in a spreadsheet depend on another and update the latter, the former updates automatically, but that does not happen in programming languages. So let's say you have like in a spreadsheet, you have created a formula that adds cell A1 and cell B1 and gives you the sum of those two numbers. And if you change one of those two cells, the sum will change as well. But this does not really happen in programming languages. So keep in mind that variables only change value when something is assigned to them. For example, if we create variable 1 that equals to 1, and then in a new line, we say variable 2 equals to 5 times variable 1. And then you change the value assigned to variable 1 again. That equals to 2. If you print first is comma variable underscore 1. And second is variable 2. And if you do that, the value that is going to be printed for variable 1 is the last one assigned to variable 1. In this case, it's 2. But for variable 2, is the variable that is calculated based on the first variable one value. So in this case, it is 5. Now let's do a couple of short exercises. Let's see. So would you like to tell me what type of value is 3.25 plus 4? Anyone? Let's see. Float. Yes, that is correct. So this is a float. Even though 4 is an integer, when you add an integer to a float, the result is always going to be a float. And the same happens when you use division. For example, when you say variable, let's create a new variable called division equals to 5 by 2. Both of these numbers are integers, or let's say 4 by 2. That gives you kind of a whole number. And then you say print div. Okay, let's quote this out. There you go. You see that even though the result is a whole number, it's the number 2, you get a float data type. So it doesn't really matter what the result of a division is. The result will always be a float. So keep that in mind. And you can check that by saying type and parentheses. It will tell you that this is a float now. Right, so let's move to the next chapter. Yeah. Do you have any questions so far? Is everything clear? Let me know. So we're going to do the next. Great, thank you for the thumbs up. We are going to do the next chapter, and then we're going to have a short break. So like we did previously, go to File, a new notebook, and let's create a new Jupyter notebook. I'll save this one and close it. There you go. And we are going to rename our new notebook Building Functions and Help. So in this chapter, we are going to explain the purpose of functions. We are going to show you how to correctly call built-in Python functions. We kind of introduced some of them, like the print function, the type, and the length functions, or all of these are built-in Python functions. We can nest calls to built-in functions, like we did with the print and then type. So we nest one function to another. And then we're gonna see how we can use help to display documentation for built-in function and correctly describe situation about specific errors you might encounter. I already demonstrated that previously, but I'm going to explain it a bit more. If you want to add some documentation or some explanation about your code, you can use the hashtag symbol, and whatever you add after the hashtag is not executed by Python. So if you run this cell, nothing happens. So this is kind of what we call a comment on your code, and you can use that as documentation to add documentation or comments about your code or explanation of what this specific piece of code does, so you can remember when you revisit your code in the future. So let's create a new variable called adjustment and assigned this 0.5, this value to it. So you can add comments on the same line as your code, as you know, if you use the hashtag symbol, Python won't execute that. So it doesn't matter where it is. If it's after the hashtag, it is not executed by Python. Anything after the hashtag is ignored. And as you can see, it does have a different color as well. It has like kind of light greenish sort of color, and it's different than the rest. Variables have this black color, numbers have like this green color, and so on. So so this is how we add comments into our code for documentation purposes. So let's move to the functions that we mentioned earlier. We have seen some functions already. So len, some functions may take 0 or more arguments. For example, the length function takes exactly 1. The integer, string, and float functions create a new value from an existing one. The print function takes 0 or more, and with no argument, it prints a blank line. But remember that you must always use parentheses. The argument is the value that is passed into a function. For example, if you say print and then before, and you say print parentheses and leave it empty, and then print after. If you execute this cell, you see that you have like this argument that is passed to the print function, and then an empty line, and then the second argument, which is after. Now, every function returns something, because when we execute the cell, we say that we call this function. In this case, we call the function print, and it always returns something. If the function doesn't have a useful result, it usually returns the special value none, which in Python stands in anytime there is no value. For example, let's create a new variable called result that equals to print. And then in a new line, say print result, print is, comma, result. So here in this example, you see that the value we have assigned to result is the print output of example. And then when we try to print result, we get none because there is no value. This is kind of the we just call the print function and we pass this example argument to the print function. So this is not a value that is passable to this variable. So we get this special value none. Now, there are some other commonly used built-in functions that are the max, the min, and the round. And if you performed any statistical analysis before or kind of descriptive statistics, the most basic descriptive statistics, you encounter them, of course. So we use the max function to find the largest value of one or more values. We use the min to find the smallest. And they both work on character strings as well as numbers. But keep in mind that larger and smaller use a specific order. So I will add this comment. So larger and smaller use from 0 to 9, so all the numerical values, then capital letters, and then lowercase letters. So if you have, let's use the print function and say, give me the maximum of 1, 2, 3. And then I want you to print the minimum of A, comma, A in quotes, and then 0. Oops, 0. There you go. The first one will, of course, give you the maximum value. In this case, because they are numerical, it's the number 3. But the minimum of all of these 3 strings is 0. Because, as we said, it starts from all the numerical strings, let's say, are considered the smaller value, and then it moves to the maximum, which is the lowercase. So if you type max, it will give you the lowercase a. So it goes from smaller to larger in this order. Do you have any questions so far? No? Great. Now, functions may only work for certain combinations of argument. For example, maximum and minimum must be given at least one argument. And they must be given things that can meaningfully be compared. For example, if you try to compare, if you add the number here, you get the first print, which is 3, but the second one, you will get a type error because this comparison between strings and numbers, it's not supported. In which case you will get an error. Functions also may have default values for some arguments. For example, if you want to round up a number, by default rounds to 0 decimal places. So when you use round and then in parentheses 3.456, it will round to the closest integer. If it's over 5, even slightly, it will round to the closest integer up. It will round up to 4. You can specify the number of decimal places if you want. So if you want to have like 1 decimal place, then it will go to the closest float with 1 decimal places. Let's see now. So functions are also attached to objects that are called methods. This is super important. To understand what methods are. When functions are attached to objects, they are called methods. So functions take another form that will be common in the pandas episodes that we're going to cover later on. Pandas is a very commonly used library or module, as we mentioned earlier, that we can call into our Jupyter Notebook and reuse. So methods have parentheses just like functions, but some come after the variable. For example, let's create a new variable called myString that equals to hello world. There you go. So we have created a new string object. And let's use print and get the length of this string object. And in a new line, let's say print myString swap case. And in a new line, and I will explain what that does. MyString dot double underscore len double underscore and then parentheses. And let's execute this cell. Right, so on the first line, we have created a new variable and we have created a new string object, which is hello world. And then on the second line, we use the length function, which takes a string as an argument in this case, and returns the length of the string. In this case, the length of the string is 12. So it consists of 12 characters, including this empty space in the middle. The third line, we use the swap case method in order to swap lowercase letters into uppercase and vice versa, which returns this one. And the last one is we're calling the internal length method on the myString object. And this kind of, we're not going to use them that often for the rest of the lesson, but just remember that there are some internal methods that can be used in Python. In this case, we use the internal length method in order to get the length of the string, which returns the same thing as the length function. So when a function is attached to an object, like in this case, it is called a method. There is also another very, very important built-in function in Python that is called help. And we use it when we want to get online documentation about specific functions. So you can type help, and then let's say you want a bit more information about the round function. If you execute the cell, you will get the documentation on the round function. In this case, it tells you that it helps on built-in function round in module built-ins. So it rounds a number to a given precision in decimal digits. Here is a number, and then you can add the number of decimal digit if you like after a comma. So it explains what it does and how you can use it. Now, do we have any questions so far? No? Great. So in Jupyter Notebook, you can you have a couple of ways to get help. One is hold down the Shift and press Tab. So if you place the cursor near where the function is invoked in a cell, for example, here or here, and you hit Shift and Tab, you will also get the documentation on this function. So in this case, we get documentation on the help function, now we get kind of what is executed. If you pass an argument in the help kind of function, you get the documentation in the argument, in this case, in the round function. The second option is type the function name in a cell and then add a question mark after it. And this also gives you the documentation on this specific function, but in this case, it opens a new window that you can close. And you can do that if you don't want to kind of crowd your notebook with this information. You can get the documentation and then close the window. Now, we're going to talk a bit about the different errors that we get in Python, and then we're going to have a break and come back in around 50 minutes or so. So yes, we're just going to cover this short bit and then go on break. Right, so let's go back to the lesson here. Just click on built-in functions and help. And scroll all the way down. And go here to Python reports a syntax error when it can understand the source of a program. Now, if you forget to close the quote marks around the string, you will get an error, in this case, a syntax error. If you have an extra equal sign in the assignment, you'll get another syntax error. If you forget to close the parentheses after when using a function, you will get an error. So if you look a bit closely to your error messages, the last line, as we mentioned, is the most informative one, but it also indicates where the error occurred. So in this case, it gives you like this tiny symbol and tells you, you know what, this is where I encountered the error because I was expecting a parenthesis and I didn't find it. So keep look more closely at the error messages, and unless it's something that is beyond your knowledge, you will be able to understand what this error refers to, and hopefully you'll be able to fix it. So the message indicates that it encountered an error on the first line because we only have one line, and it shows you where exactly. So Python reports a runtime error, which is a different type of error in Python, when something goes wrong while a program is executing. So we covered the syntax errors, then we have the runtime errors, for example, age equals 53, and then remaining equals 100 minus age, or something like that. I'm not sure how it's spelled. So this is misspelled, as you can see, and it's not the variable that we created earlier. In this case, you will get a name error because it tells you that this variable is not defined. I'm not sure what this refers to. So if you have like a misspelled variable or something like that, then you will get a runtime error because when Python tries to execute this program, it encounters an error, and in this case, it's a name error. You can fix syntax errors by reading the source and runtime errors by tracing the execution. It also, so if you look closer to the error, it also shows you where it encountered this error, in this case, runtime error. So it tells you it's on the second line. So you have to look closer and trace the execution. Yeah, I won't go into too much detail. So because we're running a bit late, so I will let you go on a break, and yeah, please be back by 15 past 12, if that's okay. And let me know if you have any questions. Yeah. Great. So yeah, see you back in around 15 minutes then. Okay, welcome back, everyone. Hopefully you had a nice stretch. Just use the react buttons to indicate that you're back. Just wait for a minute or so for everyone to come back. Right, so if you're back, let's do the same thing that we've done already. Let's create a new Jupyter notebook. Let's go to File, New Notebook, Python 3. Let's close the previous one. And we are going to rename this one Libraries. In this chapter, we are going to explain what software libraries are and why they were created and how we can use them. We're going to write some programs that import and use modules from Python's standard library. And we're going to find and read documentation for the standard library interactively and online. Now, as we mentioned at the beginning, one of the biggest strengths of Python is that it is modular and we can reuse piece of code that other people wrote. And these modules, in this case, they're called libraries. So a library is a collection of files. Those files are called modules that contains functions for use by other programs. It may also contain data values. For example, the pi number might be stored in a library. And libraries' contents are supposed to be related, but there is no really way to enforce that. So, for example, there are some libraries that are used for machine learning. There are some libraries like the matplot library that is used for visualization. So there are different libraries for different things, but some of them are more kind of generic, let's say. The Python standard library is an extensive suite of modules that comes with Python itself. And there are many additional libraries that are available from Pi, which is spelled like this, from Pi, which is the Python package index. Now, in order to use a library, we have to first import it into in this case, our notebook. So we have to use this special kind of function called import. We use import to load the library into a program's memory, and then we keep referring to things from this library in a specific way. For example, let's say that we want to import the math library. Then if we want to reuse things from the math library, we say pi is, and then we use the module pi from the math library. And you do that by adding the name of the library followed by the name of the library dot and then the name of the module, in this case pi. So the pi number is stored as kind of a data value in the math library. So think of it as a variable that has the value of 3.14 and so on, that is stored in math library, and we don't have to define it. We just call the library and we call this specific variable or module from the library. Now, if you say print and then in parentheses, the cosine of pi is, and after the quotes, say comma math cosine and then math.pi. This is what you will get. So the pi number is 3.14 and so on, and the cosine of pi is -1. Now, you have to refer to each item with a module name. So we have the cosine and the pi, but if you say math.cos of pi, this won't work because the reference to pi doesn't somehow inherit the function's reference to math. So it has to be like a math.cos of math.pi. Now you can use the help function that we learned in the previous chapter to learn a bit more about the contents of a specific library module. And it works just like the help for a function. So if you say help and then in parentheses, you pass as an argument the name of the library, in this case, math, then you get all the documentation on the specific library. And it basically gives you all the content of the library. So it tells you that the name of this library is math. It gives you a short description. It tells you that this module provides access to the mathematical functions defined by the C standard. And then it gives you all the functions that you can use, like the cosine that we use already and so on. And as we mentioned, libraries might have stored values like the pi. This you will find that under data. So in this case, we have e, inf, nan, pi, and daf. So it has some data stored as well that you can refer to if you like. Any questions so far? Great. Now, you can import scientific items from a library module to shorten the program. So in this previous example, we imported the whole math library, but let's say you might want to only use the cosine and the pi from the math library, so you don't need to load the whole library and make your program heavy. So in order to do that, you say from the math library in this case, or from the library that you want, import cos and pi. So I don't want Python to import the whole contents of the math library. I just want these two things from the math library to shorten your code and make your program a bit lighter. And then you can say print, and then the cos of pi, the cosine of pi is O, and then you say cos pi. So you might have noticed that now you don't have to define, we don't have to say math.cos or math.pi. This is because we specifically imported these two from the library directly. So when we call them, Python knows exactly what we're referring to. But if we loaded the whole library, then we had to specify which modules from this library we want to use and how. So you have to define the library as well. Now, what is a very common practice in Python is to create aliases for library modules when we import them in order to shorten our programs. In order to do that, we say import. In this case, let's say import the math library and then say import as m. So instead of typing math.cosine or math.pi, you just have to type m. So we give the alias m to the math library to kind of shorten our programs. So in this case, we say the cosine pi is comma m.cos and then in parentheses m.pi. Instead of typing math and so on. So math, you might think that, okay, math is not such a long name, but there are libraries that have longer names, and using aliases is common practice. And there are specific aliases that we use. So it's not mandatory, but there are some common aliases that we give to specific libraries. You can name it whatever you like. You can say import math as balloon or something. You can name it whatever you like. But there are some common aliases that we give in order to keep things consistent and relevant that we're going to talk a bit more later on. So let's do a short exercise. What I'd like you to do is tell me what function from the math module can you use to calculate the square root without using the square root one. And then the second one is, since the library contains this function, why does square root exist? So just to remind you, you can use the help function to go through the contents of the library. Right, so this is another exercise that I'd like you to do. I'm not sure if I was muted before when I was explaining the difference between POW and square root. Let me know. Okay, right. I will repeat that then. So yes, POW is the correct answer. This is another way of getting the square root of a specific number. So, for example, x to the power of y. So there are two ways of getting the square root of a number. You can either use POW or you can use square root. So this is the answer to the first question, but for the second one, since the library contains this function, why does square root exist? This function exists because this is a very common, let's say, equation that we use in math. This is a very common case, and it exists because of readability. Readability is very important in programming languages, and it's very important in good programming in terms of effectiveness and efficiency. And in square root, you only need to pass one argument, but in POW, you need to pass two arguments. You need to pass the number and then the power. So it is arguably more readable to use a square root instead of POW. So another exercise that I like you to do is this one at the bottom. So you can I want you to fill in the blanks so that the program below prints 90. And then I would like you to answer if you find this version easier to read than preceding ones, and why wouldn't programmers always use this form of import? So we'll give you a few minutes to do that and then answer in the chat, or we can go through it together. Great. So let's answer this question. In order to fill in the blanks, we need to import from the math library. We need to import degrees and pi. So the angle variable equals to degrees, and then times pi by 2, and then we print the angle. So this returns 90. If you're not sure what degrees refers to, if you go to the documentation, you'll see that degrees converts angle x from radians to degrees. There you go. So that is all for libraries so far. So let's go and create a new Python notebook. So save this file. Again, go File, New Notebook, and Python. And let's rename this new notebook Reading Tabular data into Python. Rename. Great. So in this new chapter, we are going to import the pandas library. Is anyone familiar with the pandas library? Have you used it before? Just give me a reaction or unmute and let me know. Yes. No. No. No, only heard of it, not used. Have used GeoPandas. I guess again something more specific to geological sciences. Great. Okay. So the pandas library is another Python library that is very, very, very commonly used in Python. We are going to use it in order to load a simple CSV dataset. Are you familiar with CSV? Do you know what CSV stands for? So CSV, yes, yeah, great. So CSV stands for comma separated values. So basically, it's a file format that stores your data in kind of in a format that's separated by commas, and it's kind of a text file that you can load either in your like spreadsheet program or Python, and it's kind of very lightweight. And it's not program specific either, so you can open it with many different ways. And it is usually the file type of choice when you're dealing with data. So we're going to use pandas to load the simple CSV dataset. This is where the data that you downloaded earlier are going to be used. And then we're going to get some basic information about a pandas data frame. And I will explain what that is in a minute. Now, we're going to use the pandas library to do statistics on tabular data. And as I said, pandas is a very, very widely used Python library that is used for statistics, and more specifically on statistics on tabular data. Has any of you used R before? Yes, very little. Okay, if you're familiar with R, yeah, they are programming language, or yeah, if you use it for data analysis. So it borrows many features from the R's data frames. So you have a two-dimensional table whose columns have names and potentially have different data types. So you can load the pandas by using the special word import and then pandas, which is the name of the library. And as we mentioned in the previous chapter, we use aliases to shorten our programs. The most commonly used alias for pandas, for the pandas library, is PD. So we import pandas as PD, and then let's create a new variable where we're going to store our data. And our new variable is going to call data underscore Oceania. And that equals to PD, which is our library. And then we are going to use the read underscore CSV function of the library. And then if I go back to my file, to the file that I have, to the new folder that I have created earlier, where I stored my data and where I created my Jupyter notebooks, I'm going to find all my data in a folder called data. And this is where everything is. So I have my folder with my Python notebooks and my folder with my data. In this case, because all of them are stored in the same folder, I just need to define the name of the folder where my data are, in this case, data, and the name of the specific file that I want to access. In this case is gapminder underscore GDP underscore Oceania .csv, which is the file type. And if you do that, you might not see anything at the moment, but Python has uploaded the CSV file into the kernel, and it is stored in the memory behind the scenes. If you add print and then the name of the variable that we created, you will see that we have successfully uploaded our data. Do we have any questions, or do you have any issues uploading your data?
Dana, would you like to show the folder structure from Jupyter tab, from the second tab of the browser, and
Yes.
maybe create a notebook around that?
Yes, of course. So as you can see on desktop, I have created a folder called Carpentries, where I have different workshops. This is today's workshop. So I created a new folder, and in this folder, I have unzipped my data, as you can see here. So I have a folder called data. And in the same folder is where we created the new Python notebooks earlier. So as you can see, they're all stored in the same folder. So when you try and call like a specific data file, just because they are in the same directory, you just need to define the path where your data is stored. So in this case, you say to Python, go to this folder, the data folder, and get me the Oceania data, which is what we did here. So data / gapminder GDP Oceania. Does that make sense? Don't need that.
Thanks. Everybody, please try that, and if you need time, please let us know, and also let us know if it's not working. Thank you.
Yes. Thank you, Anasi. Great. So I assume that everyone was able to load their data successfully. So let's start with some operation, let's say. You might wonder why it looks like this. This is because the columns in a data frame are the observed variables and the rows are the observations. So you can see that you have two rows, Australia and New Zealand. And as I mentioned earlier, indices in Python start from 0. So this is the default index that Python gives to your data. And this forward slash indicates a break in the line. So you can see that you have Australia, New Zealand, and it is the same for the rest. Australia and New Zealand through the years, basically. It just breaks it into different lines. Also known as wrapped lines. You can, by using the descriptive data frame names, it helps us distinguish between multiple data frames, so we won't accidentally overwrite a data frame or read from the wrong one. So you can use the index underscore call to specify that the columns value should be used as row headings. And you can do that by creating a new variable called data, Oceania underscore country, and that equals to pd.read underscore CSV, which is a function that we use from the pandas library in order to read our CSV files, and then data underscore gapminder underscore GDP underscore Oceania. And then you specify the index call. So basically which column you want to use as your index. Because as I mentioned earlier, Python will give you a default index, which is these numbers here of 0 and 1. But let's say that you want to use a unique identifier in your data as index, in this case, the country. You can do that when you're loading your data by using the index column. So then you say print parentheses, and then you can copy and paste. Okay, let's see. File not found error, not set file on directory. Okay, let's see. I forgot the CSV at the end. There you go. So as you can see now, we don't have these default indices that Python gives because we have defined a column from our data as our index. And indices have to be unique identifiers in your data that you can use. In this case, our unique identifier is in the countries in our data.
Sorry to interrupt the line. One person is facing difficulty in importing the data. So would you like to show the tabs again and the Jupyter Notebook creation?
So what is, could you share the error message that you get so we can help you? Okay. File not found, read CSV, data, government. So have you stored your data in the same folder as your Jupyter Notebook? Let's go back. So I have created this folder in my desktop, right? And this is the folder where we created new file, our new Python file, the first one. And this is where all of our Python Jupyter notebooks exist. They exist in the same folder as our data. Is your Jupyter notebook in the same folder? Do you have a folder, a data folder, or do you have just your data loose in the same folder as your Jupyter notebooks? Yeah, so yeah, if they are in different folders, then you need to specify the path. That's why we said it is very important to have both your notebook and your data in the same folder. So otherwise, yeah, you won't get the path. So the quick fix would be to copy your data folder and paste it in the same folder where your Jupyter notebook is. And let us know if that works. Great. Great. All right. So let's see where we're at. Right. So yeah. So we have now defined a new index for our data. So let's use a different method to find a bit more about our data frame. And in order to do that, we say data underscore Oceania country dot info. And by using the info method, we get more information about our data. And this tells us that we have 2 entries, Australia to New Zealand, and we have 12 columns. These are all the names of our columns. These are the 2 entries that we have. So these are the number of the rows. This tells us that all columns have values in it, so that we don't have any null values, and the data types are all floats. That's great. So this is our data frame. 2 rows name Australia and New Zealand, 12 columns, each of which has 2 actual 64-bit floating point values, and it also uses 208 bytes of memory. Now, you can also use the columns method, and that will store information about the data frame's columns. So if you type print and then data Oceania underscore country and then columns, it will give you information about the different columns. So it will give you all the different column names that are stored in your data frame. These are all very, very useful practices, let's say, when you try to clean your data. So for example, let's say that you have one column that has no values at all. You might want to remove it from your data, or you're expecting for all your data to be numerical and one of them has a string instead of float, which means that you need to convert your data types. Or you need to make sure that you have the specific information about year 1982, and you need to make sure that you can find it in this data frame, and so on. So we use that fairly often when we doing the data cleaning and data wrangling. Another quite useful method that we can use is the transpose method, which is symbolized by capital T. So if you want to treat columns as rows and vice versa, you can transpose your data frame. And you can do that by saying data underscore Oceania underscore country and then followed by capital T. If you do that, then you will have your columns as rows and your rows as columns. And so, yeah, you might find it more useful for specific operations that you want to perform with your data. Now, another method that is really, really super important when we're dealing with data in Python is the describe method. It's very, very very commonly used because it gives you summary statistics about your data. For example, you say print data underscore Oceania underscore country dot describe. So if you run that, you get descriptive statistics. So you get the count, the mean, the standard deviation, the minimum, and then the different percentiles, 25th, 50th, 75th, and then the maximum value. So this is also very important when you need to see, the bounds, the different values that you have, the mean or the standard deviation, some an overview of the descriptive statistics of your data. Now, what I'd like you to do is read the data of the Americas CSV that you'll find in your data. There you go. Let me wrap this line around. There you go. So read the data in Gapminder GDB Americas.csv, which should be in the same directory as your Oceania CSV. And I want you to read it into a variable called data underscore Americas and display its summary statistics. Okay, so let's do that. Let's create a new variable called data Americas that equals to PD, which is the name of our library, and then read CSV, and then in parentheses, quotes the name of the file. And then we want to print. Basically, we're going to do the same thing as we did here. Data underscore Americas. And then, oops, sorry. Let's describe. There you go. There you go. So now we have the descriptive statistics for the Americas data, the Gapminder GDP Americas data. Okay, let's see. Do we have any questions so far? Great. Right, so let's save this file, and then let's create a new notebook. So you might have noticed that every time we create a new Jupyter notebook from an already existing one, so if you say file, new notebook, it creates the new file in the same directory as the previous one. So here you have a nice collection of all the different notebooks that we created today together. And they're all stored on the same directory as the very first one. So you start with the first one by going into the directory where you have your data stored, new Python 3. And you can continue doing that, or you can go to File, New Notebook, and you can create it this way. So both ways will work. So let's rename our new notebook as pandas data frames. And we're going to have our lunch break after this one, or maybe halfway through this one, because this is a big one. All right, so in this chapter, we are going to select individual values from a pandas data frame, select entire rows or entire columns from a data frame, select a subset or both rows and columns from a data frame in a single operation, and select a subset of a data frame by a single Boolean criterion. Now, a data frame is a collection of series, and it is the way that pandas kind of represents a table. And series is the data structure that pandas use to represent the column. Now, what makes pandas so kind of attractive is the interface, where you can access individual records of the table, and you can easily access like kind of missing and handle missing values and relational databases, operations between data frames. Now, let's say that you want to select specific values by their entry position. You can specify the location the same way we specified the indices when we introduced the strings. In the same way, you can use the indices to select specific values. So let's start by importing pandas as PD. And because we have a new notebook, we have to import our libraries from scratch. So if you import pandas at the beginning of your notebook, you will be able to use pandas throughout your document. But when you create a new document, a new Jupyter notebook in this case, you need to import your libraries from scratch. So within the same document, values and libraries are transferable. They're stored in the background memory. But when you create new notebooks, you need to import libraries from scratch. You need to define your variables from scratch and so on. Now we have imported the pandas library, and then let's create a new variable called data that equals to pd.readcsv. And you know the gapminder underscore GDP underscore Europe.csv. And let's create, we want to use our country column as our index. So we use index underscore col equals to country. That's great. So we are going to import our Euro GDP data, and we're going to use the column country as our index, and we store all of these under the name data. So when you print data and you want specific parts of your data to be printed, let's say you want the first the value that exists in the first column and the first row, you use the I-log, which stands for index location, and then square brackets 0, 0, which stands for the index 0 for the column, for the row, and index 0 for the column. So when you execute that, you get this value here. So if you print data, you will see that the first value of the first row and the first column is this one, which is the GDP per capita for 1952 for the country of Albania. Now, if you don't want to use the index location, you can select values by their entry label. So you can specify the location by row and or the column name. So in order to do that, you say print data and then log, which stands for location, square brackets, and then Albania, and then GDP per cap underscore 1952. And this will return exactly the same value because it is the value that is in the first column and first row. And then you can, instead of using the index, you can use the labels. Any questions so far? Great. So if you remember from earlier when we use the slices in our strings, when we wanted a specific part of our string, we use the slice of it, and we use the colon. We can use that here as well. So if you use a colon on its own, that means that you want all the columns or all the rows. So if you say print data and then location log, and you define the name of the row, in which case we want all the data for Albania, followed by a colon, then this will return you all the data that is stored in this kind of row for Albania. And this gives you kind of a slice of your data frame. If you want specific information for a specific country or a specific year, which means, let's say that you want all the information for the GDP per capita for the year 1952, you can do the same as previously, but now you put the column at the beginning and not the end. So colon, comma, and then the name of the column. So the first number in the square brackets, when you're defining the location, refers to the row, and the second one refers to the column. That's why you put the column here in this case and the column here in this case. So this will give you everything, every data on this row, and this will give you every data in this column. So now we have the GDP per capita for the year 1952 for all these countries. Any questions so far? Let's see. Yes, great. You can select multiple columns or rows using the data frame location and a named slice. For example, if you say data, dot location, and then square brackets, you say Italy to Poland. And then GDP haircut 1962. To GDP per cap of 1972. So this will give you a slice of your data frame instead of a specific year or specific country or a single value. This will give you a slice. So from Italy to Poland and from 1962 to 1972. In this slice, you might have noticed that using the location is inclusive at both ends, which is different from slicing with the index location. So when you're using the index location, the first one is inclusive, the second one is excluded. You're excluding the final index. But when you're using the location, both ends are inclusive. So this is kind of an important information when you're using these two. So you need to remember that. Now, you can use the result of a slicing in other operations because you don't just print a slice. You might want to use it for something, for some analysis or for some a specific operation, for example. In this case, let's say that you want the maximum. So you say, if you use the max method, then you will get the maximum value for each. Now, if you want to use the minimum, similarly, you add the minimum method at the end. Now, you can use comparisons to select data based on a specific value, and the comparison is applied element by element. So you can use a subset of your data to keep it readable. So subset equals to data.location, Italy to Poland. And then let's copy this bit here. GDP per cap. There you go. So now you have saved this slice. You have stored it in a variable to keep everything nice and clean. So now you can perform, say, you have a subset of data. Great. And then if you want to find out which values are larger than a specific value that you define, the threshold, then you can say print and then add this string to explain the output and say subset larger than 10,000. And this will give you what we call a mask, a Boolean mask. Boolean means that it has kind of two values, true or false. It returns where in the output it returns true or false values where this condition is either true or false. So in this mask you have Italy doesn't have a value more than 10,000. As you can see here, neither does Montenegro, but Netherlands and Norway do. So as you can see here, we have false, false, true, true, and so on. Great. So I would say that we should go on a break and get back in around half an hour and continue with the pandas data frames, if that's okay with you. Yes, and thumbs up or down. Great. Right, so see you back at say, I know we are all, well, not all, but some of you might be on a different time zone. So I would say get back here at like in 30 minutes time. It is 20 past 1 in the UK right now. So if you're in the UK, let's say 10 to 2. Welcome back. Hopefully you had a nice break. So only about an hour left. So you're doing great so far. We have a couple of more things to cover, and then you're free to go for the day, and we will resume tomorrow. So you've been great. You've done great so far. Big applause to you. Is everyone back from their break? Just give me a thumbs up. That's an indication to make sure that I'm not talking to the void. Yeah, we had a couple of thumbs up. Yeah. Great. Great. Right. So let's continue. We have we've talked a bit about slices and masks and how we can get a specific subset of our data if you want to perform specific operations like specific statistical operations, for example, or comparisons or so. So now let's talk about the none values using a Boolean mask, which is the same thing that we did here, but for the none values. Now, a frame full of Booleans is sometimes called a mask because of how it can be used. So let's create a new variable called mask, and then subset of all the subset values that are over 10,000, and then print the mask. So when you do that, here we said what are, well, this is kind of, let's say, width values are large. And we got this Boolean output here, where we had false and true values where this is true or false. But when you use this variable, in square brackets in your subset, you basically create a mask where it only shows the true condition. So wherever this is true, wherever the subset number is over 10,000, these are the only values that are showed here. And the rest are replaced by none, which stands for not a number, because it does not fall into this category. There are values that are lower than 10,000, so we don't want them. So it kind of creates this mask where only the values that are over 10,000 are displayed. Now, we can also group our data and group them by a specific condition. Pandas are vectorizing methods, are grouping operations, and are features that provide users and much flexibility to analyze their data. An example is, let's say that we want to see how the European countries kind of split themselves according to their GDP. You might want to create two groups of the countries during the year surveyed, and those who represent the GDP higher than the average and those that are lower than the average GDP. And we can estimate something that's called the wealthy score based on the historical data, where we account how many times a country has participated in the groups of lower or higher GDP. So how many times a country had a GDP that was over the average or under the average. So we can do that, create a new variable called mask higher, that equals to our data, where our data we want to show us the data where the data is over the mean. And then let's create another variable called wealth score, where we have a mask higher and then the aggregated score. So this is a method called aggregate that gives you the aggregated number. Or the summary where axis equals to 1. And I will explain what this axis means in a bit. Print wealth underscore score. Right, so what that does, let's execute this cell and we'll explain what that does. Right, so we created a new variable called mask higher that kind of shows our data where our data are larger than the mean. And then we create another variable called wealth score, which equals to the aggregated number of this column. So axis equals 0 means perform this on the rows. So axis equals 0 means rows, and axis equals 1 means columns. So yeah, do that on the mask higher variable, which is all our data that are over the mean, then divided by the length of our columns, the columns that are in our data, in which case you have to go all the way up. So this is kind of the data from the European GDP. So these numbers for each group in the wealth score table, we sum their financial contribution across the years surveyed, used chained methods. So say print, and then in parentheses data group by, and wealth underscore score dot sum parentheses. So this here basically it sums all the contribution for each group in the wealth score, which is here. It groups their sum across the years surveyed using chained methods. So it groups it by their wealth score, basically. It identified 4 different wealth scores: 0, 0.33, 0.5, and 1. And these are the aggregated scores for each of these categories, let's say. So it groups all the countries that have a wealth score of 1 into one group, and then gives you the sum and the aggregate score, let's say, and it does that for all the other countries as well. So do we have any questions so far? No? Great. Now, let's do a short exercise. Okay, let's do this exercise. I will add this in the shared document. And I would like you to copy and paste it in your notebook. And once you do that, I would like you to actually do something which is kind of, I will demonstrate how you can convert this from a code cell into a markdown cell. And markdown cells, you can think of it as kind of a text editor, sort of, that you can add these pieces of text that explain your code or to kind of accompany your code. So in order to convert this cell from a code cell, so code cells are all the cells where you write your code and you execute it. Markdown cells are cells that hold text or information, and they're not executable. They don't give you any existing text format. You can go to cell and then cell type and click on markdown. And when you do that, you can see that this is different from the code cell. If you execute that, it now converted it into kind of text that you can select. So this is a code cell, this is a markdown cell. So I won't go into too much detail because there are different things that you can do in markdown cells. For example, if you add an asterisk in a markdown cell, it gives you everything in a list. But I can give you some links if you want to further explore that. So go ahead and do this exercise, and we can then move on to the last part of the workshop. Right, so do we have any idea how we can do the first one? We have an answer. Let's see if it works. So we want the GDP per capita for all the countries in 1982. And that is correct because we use the colon. Because that means that include all the rows for this column, all the data for this column for the year 1982. That's great. So let's do the same for the second one. Do we have an answer for that? Yes, let's try that. So we have, we want the GDP per capita for Denmark for all the years. Similarly, we say we use the log method, the location method, and we get the GDP data for all the years for Denmark. Then we have the GDP per capita for all the countries for years after 1985. So that might be a bit tricky. Do you have an idea how we can do that? Let's try that. So yes, so you can use the column for all the rows, but also you can use it as kind of part of a slice. So when you say the GDP per capita from 1985, and remember this is a location method, which means this is inclusive. So if you want GDP per capita for all countries for all the years after 1985, you say, I want all the countries, which is all the rows. And from the columns, I want everything after 1985. It goes up to 2007. So the location one, yeah, so this is the location method, basically. And then we have the last one, which is GDP per capita for each country in 2007 as a multiple of GDP per capita for that country in 1952. So how we can do that? So for the last one, we say data and GDP per cap for the year 2007. And then we can divide it by the GDP per capita for 1952. And this will return the GDP per capita for all countries as a multiple of their GDP for 1952. So Switzerland has almost doubled their GDP. Spain, well, has increased it by 7.5 times, and so on. Right, so let's save this notebook and let's create a new one, the last one for today. And we are going to name this one plotting. Rename. Right, so in this chapter, we are going to create a time series plot showing a single data set, because we have some time series data. And then we're going to create a scatter plot showing relationships between two data sets. So as I mentioned earlier, we have different libraries for different things. One of these libraries is the matplotlib library, which is one of the most widely used scientific plotting libraries in Python. And by using that, Python will create some nice plots for us. Let's create an example. Let's create a new variable called time that has the values 0, 1, 2, and 3. And in a new line, let's create a new variable called position that has the values 0, 100, 200, 300. So if we want to plot the relationship between these two variables, we can we first need to import the matplot library. So we have import matplotlib, it stands for my matplot library, dot pyplot as PLT. So pyplot is a sub-library of the matplot library that we can use. And by using that, the Jupyter Notebook will render plots in line by default. So we imported the library and then we say PLT, which is the alias that we gave to our library. And then plot time position. So these are the two variables that we want to visualize. The PLT X label, this is how we define the labels for our x-axis. Time in hours. And PLT.y label is how we define our y label. It is position. That is in kilometers. There you go. So as you can see here, we use the time, the values in our time variable that are stored in our time variable as our x-axis, and then all the values that are stored in our position variable as our y-axis. And then we added the x and y labels. And then Python created this nice plot with the relationship between the two variables. Now, if you, sometimes some Python environments, like an interactive Python session, started from a terminal or a Python script executed via the command line, require an additional command to display the figure, which is the PLT show. Stands for that. And this command can also be used within a notebook, for instance, to display multiple figures if several are created by a single cell. So you can do that if you can. So you can create multiple figures in one cell, and then via the PLT show, it will display all of them. Now you can pull out data directly from a data frame. For example, let's say import pandas as PD, because this is a new notebook, so we need to re-import our libraries, and then let's say data equals pd dot read underscore CSV. Let's get the data gapminder underscore GDP underscore Oceania again dot CSV. And let's use our column, our country column as our index. So let's say index underscore col equals country. So if we want to extract year from the last 4 characters of each column name, because as you remember, it had like the GDP per cap and then the year, we can remove the GDP per cap part of it and then leave only the year. We can do that by saying years equals data dot columns dot str dot replace in parentheses GDP per cap underscore comma and then an empty string. So what we ask Python to do here is asking to replace the string that it finds in the column names of our data frame with an empty string, thus leaving only the year. You can also convert the year values to integers, and you can save that back to a data frame by doing data columns equals years dot as type integer. And then we're going to plot that. And we're going to use these years as numerical data to use for our plot by using the location, Australia, dot plot, and then parentheses. So as you can see here, we have successfully converted the column headers, the column names. We removed all the strings and we converted those numbers that were left behind into integers that we were then able to use in our plot, as you can see here, from 1950s until 2000 and something. And then all the GDP numerical data that we already had for Australia, thus giving us this nice plot here. Any questions so far?
Then we have a question in the chat
Yes.
regarding the previous plot.
Yeah.
That we supplied the integer in the x-axis, but we get the 0.5 fractions there. So is there any way to adjust those to only have 0, 1, 2, 3?
Oh, yeah. Okay. Yes. So this happens by default. As you can see here, it says text 0,0.5, which means that it will give you 0.5 increments. I think, yeah, you can adjust that. I don't remember that from the top of my head. Let me double check. There is a way of doing that. Let me. I have to look it up because I don't remember it from the top of my kind of head at the moment, but I know that there is some way, there is kind of a workaround.
The intake hub, our second helper, has noted in the chat the solution for that.
Yes, the X sticks. Yeah, that's the one. Great, thank you.
I have a question. I don't quite understand. Can you just go down a little bit? I don't quite understand the third
This
line
one.
of coding. Yes. What is that doing?
Sure. So let me.
Oh no, the fourth one. Sorry, not the third one.
This one.
Yes. So basically, the third one, you're changing the column names into integer value, so you can plot it as the x-axis. So I understand that, but I don't understand what the fourth column is right now. First one.
Right. So actually, that is what the fourth line does. This bit here basically strips all the strings that are found in the column names and only leaves the number behind. So it basically replaces the string, this string that is found in the column names of our data frame with an empty string. So it basically leaves nothing behind, only the number. So you remove everything but the number. But because this is a string, you need to convert that into an integer, which is what this is doing.
And then assign that as the data column names.
Yes. So yeah, you replace, basically you create a new variable where you store all the column names. You create a new variable where you store all the column names, but you strip all the characters. You only leave behind the number, and then you convert this number into an integer, and you basically replace your previous columns with the new values.
Yes, that's understood. Now it's the fifth. When you plot it, when you try to sort of create sub data frame using data location, you just only used Australia as the one to select the row that you need, but you didn't specify which column you need, and that's basically plot all the columns.
Yes.
Do you think you can actually specify which column you need and plot maybe only a selected years other than just the whole year?
Yes, you can do that the same way we did in the previous chapter, where we used kind of a slice of your data. So if you don't if you, let's say, want only the years, let's go back and see that. So if you go here, let's say you want only the years that are after 1985. right? Then you, instead of doing that for all your columns, you can specify which columns you want.
Okay.
So you can create a new variable and say, instead of years, kind of replace all the columns. You can say, do that, but only for this specific slice. You can do the same that you did here by using the data location.
It's just the when you plot it, when you use data location, normally in other language, you have to define what you want to select for both rows and columns. And the fact you only just defined the selection of rows, you didn't define the selection of columns, and it worked, which is obviously it's very strange, but it works. It works. So
yeah, because we did select all the rows. In this case, Australia is the row. We did select all the columns.
Yeah.
By saying, so years is basically all the columns of the data frame that we have.
Yeah.
So that's how we define that.
Yeah. Thank you very much. That's understood now.
You're welcome. Because we kind of replaced all our columns here with a new numerical version of the column names, basically. But yes, if you don't define anything else and you say everything for Australia, that it will plot everything that it finds for you. Do we have any other questions? No. Great. Right, so let's move to the next bit, which is selecting and transforming your data and then plotting it. So in order to do that, we can say, let's say that we want to transpose our data in order to plot them. So we use the capital T, which stands for transpose, and then let's create the Y label, which is GDP per capita. Oh, and this similar might seem confusing because we only said, okay, PLT Y label, and then it plots everything. How does it do that? But when we transpose the data, now all of our columns are our rows and vice versa. So now we have the country, which is Australia and New Zealand. So it takes the label of the column, basically, which is the names of our countries, and the GDP per capita, which is our Y label here, and the years that are the numerical versions of the columns that we created earlier. And it gives you a nice plot where you can compare the GDPs per capita for the two countries, Australia and New Zealand. Now, there are multiple ways to plot your figures, depending on what you want to extract from your visualizations. And there are different types that might more fitting for purpose. For example, if you say plt.style use ggplot. So if you go to, let's add a new cell below. So if you say help, if you use the help method, the help function on the matplot, well, the pyplot library, you get the documentation for it, and you can see that style and use. Let's start with the style. this is quite cool. Where is it? Okay. So you can see that you have different styles. Let's start with ggplot. Might be easier to find. Anyway, I cannot find it right now because it's quite a big one. So basically, ggplot, it gives you a bit of a fancier plot style than this one, which is kind of basic. Data.gplot. You can use a different kind instead of line plot that we used at the time series, a line plot that we used previously. Let's say that you want a bar plot, so you define the style as bar plot, and then plt.ylabel, where we define the ylabel as GDP per capita. So now you have this nice bar chart that looks a bit fancier than the previous one that we used. And then instead of a line plot, you have a bar plot with the same values. So if you go to ggplot, there you go. So ggplot is basically a plotting package that gives you some helpful commands to create more complex plots. That's what it stands for. And as you can see, it looks a bit fancier. So it gives you a bit more functionality. Now, your data can also be plotted by calling the matplot library plot function directly. And you can do that by typing plt plot and then your X and Y values, for example. Now, you can do that. This is an example. Say years equals to data dot columns. So these are our new variable. It's the columns from our data frame, all of our columns and only the columns. And GDP underscore Australia is another variable that contains all the data about Australia only, without the New Zealand ones. So here we have all of our columns, and here we have all the data for Australia. And then you can say, you can plot the years, GDP, Australia, and then you can actually define the color of the line and the style of the line. So G stands for green, and these two dashes basically gives you a dashed line instead of a continuous line like this one. So when you execute this cell, you can see the same plot, but in this case, you have a green dashed line. Do you have any questions so far? No? Okay, great. Now for if you want to, let's say that you want to plot kind of multiple sets of data at the same time. You can select 2 countries worth of data by saying GDP_Australia. That equals to your Australia data. So only the data about Australia, and you can do the same for New Zealand. Data, location, and then so you have 2 different sets of data, and then you can plot with different color markers so you can compare the 2. So you can say PLT plot the years and then GDP Australia. And I want the line for Australia to be blue and continued. So 1 dash instead of 2. And I want it to label it Australia. And then you can do the same for New Zealand. So you can say years, GDP New Zealand. And I want the line for New Zealand to be green. Let's say a dashed green one. And a label that stands for New Zealand. There you go. Now you can create a legend saying I want the legend to be in the upper left corner of my plot. I want the X label to be the year. And I want the Y label to be the GDP per capita, which is in dollars. There you go. So now, as you can see, we stored our data for Australia and New Zealand on different variables, and then we created a line plot for Australia and a line plot for New Zealand, but we want both of them to be displayed on the same figure. Plot. Name plot is not defined. It's PLT. Sorry, not plot. There you go. Right, so here, as you can see, we have the 2 GDP per capita for Australia and New Zealand together on the same plot, and we kind of defined the different colors and styles of the lines. Do we have any question so far? No? Great, right. So now let's see how we can plot a scatter plot that correlates the GDP of Australia and New Zealand. We can do that by using the scatter method. So plt.scatter GDP Australia GDP New Zealand. And this gives you the correlation between the GDP per capita between these 2 countries, which basically tells you that they have a similar trajectory that is correlated at a high level. So you can see that here, you can see the correlation here. If you transpose your data, you can say data.t.plot.scatter and use Australia as your x-axis and New Zealand as your y-axis. You can define as can define the two here, and here you can see that you have the X and Y labels as well. So here are all the GDP per capita for Australia and here all for New Zealand. It is basically the same thing as this one. It is a scatter plot between the two. This is kind of a different way of doing it. So let's see if we can. Okay, yeah, that's an interesting thing. So you can, if you, let's say that you use Python to do some analysis and you want to export these plots in kind of image, in a file format, in like an image, like a PNG or so, that you can use on your report. You can do that by saying save fig. And then in parentheses, you can, I don't know, name the file, correlation Australia and New Zealand, or something like that. And you have to add the extension, so PNG. If you do that, if you go back to your file directory, you can see that you now have a file that is the exported plot from your Python node. There you go. So do we have any questions? No. You can also add figure, so between this one and this one, you can say plt.dcf, which stands for get current figure, and save it. When you go back, this is how it looks like. So you successfully saved it into a PNG image file. So this is the end of the workshop. If you have any questions, we finished a bit earlier. So let me know if you have any questions or if you need any help with anything or any clarifications. Otherwise, I will let you go about your day. Thank you very much for joining me today. I hope that it was useful, and I'm looking forward to see you tomorrow. Great. Good morning, everyone. Thank you for coming for the second day of the workshop. We will spend a few minutes discussing yesterday's workshop, and if you have any questions or if you need any clarifications or anything that you want to discuss. So if you can turn on your camera or your microphone, that would be great. If you don't feel comfortable doing that, you can type on the chat or on the shared document. I will paste the link for the shared document in the chat for those who don't have it yet.
Then, if I may add something, I was just typing that like, they can put the attendance in the Etherpad as well after you posted it.
Okay, great. So we will wait for around like 2 to 3 minutes more for people to join in, and then we can start our discussion. No, so it's a 2-day workshop. So if you have any experience with Python, Claire, you can try to keep up. But if it's the first time you encounter Python or you work with Python, it might be a bit difficult. I'm not sure if Jean are gonna share like the recording. I'm not sure how that works, to be honest. But maybe you can revisit the first day's recording and try to redo the steps.
So, sorry to interrupt you. The recording will be on our YouTube.
Great. So there you go. I think that the videos need to be processed before they're uploaded, so it might take a couple of days, a few days. I'm not sure how long, but they're not up yet for sure. So yeah, so welcome everyone. Hopefully most of you have joined by now. Welcome back. Thank you for joining us today as well. So we're going to start with some reflection on yesterday's workshop and kind of discuss if you have any inquiries, any questions, anything that you want to kind of highlight or discuss with us. You can go ahead. You can unmute yourself or turn on your camera if you like, or use the chat if you don't want to do that. Or just, just reflect on yesterday's workshop, what worked well, what didn't, so we can take that into consideration. So can you kind of maybe type what you liked from yesterday's workshop, what worked well, maybe. I don't see. Yeah, the matplot library for the visualization, yes. So there are multiple libraries in Python that you can use beyond the matplot library. This is kind of the basic one that it's used extensively, but there are some other really nice ones that are kind of, some of them are interactive as well, and they look really nice. I think Anajat shared a library of for Python visualizations that has like examples of visualization using different libraries, which is great. So if you're interested in that, you can go and check that out. If you could share the link again, Anajat, the Python repository library. The Etherpad, yes. Yeah, the Etherpad is very, very convenient because it doesn't need any, any platform to be installed on your computer, and you can share and you can keep everything in one place, and you can keep notes as we go along, and we can share stuff as well. So if you could go to the Etherpad, by the way, and just type your name to keep attendance, that would be great. The mini exercise at the end, yes, that help a lot to kind of practice what you learned. Oh, great. Thank you very much. Anjusa, thank you. It's great. So yeah, that's the library. Yeah, that's great. So yeah, I'm really happy that some of you were introduced to Python during this workshop, and you kind of learn the basics of it and how to use the Jupyter notebooks as well. They are really, really useful tools and very useful skills to have later on for your career as well. And, this is kind of an introductory workshop to Python, but then you can, there's so many resources out there, then you can go and explore it further. I usually learn by doing mini projects. So I learned by doing, the constructivism theory of learning. So I learn by doing stuff. So I work on projects and I try to do some problem solving using Python. And this is how I learn best. So maybe that's a way for you to learn a bit more about Python. And there are so many resources out there and mini projects that you can work, and you can get help on. Great. So thank you very much for your feedback. I'm going to share my screen now, and we are going to continue from... Sorry, just a second, my computer is a bit slow. So can you see my screen?
Yes.
Yeah. Yes, great. Right, so today we are going to continue from chapter 11, which is lists. Anjat shared the link in the chat. Yeah, Anjat, would you like to say something? I can see your little hand.
Sorry, there was a mistake.
Okay, great. Yeah, so yeah, there are multiple resources. We can share them after the workshop if you like to discuss that a bit further, Monjusa. So we can kind of propose a few repositories where you can work on different projects. There are a couple that are really great, and multiple people are working on the same project, and you can get a lot of feedback and support.
Thank you, Danae. Thank you so much.
Great. Right, so let's start by initializing Jupyter Notebook. So go to your search bar, whether you're using a Mac computer or a Windows one, and find your Jupyter Notebook application. And when you click on it, then a terminal will open like this, and then it will open a tab on your default browser that it will look like this. So what I'd like you to do is to go and navigate to the folder where you have your data. So hopefully you created a new folder on your desktop where you stored your data and where we have all of our yesterday's Jupyter notebooks. And it should look something like this. So you have a folder with your data and then yesterday's Jupyter notebooks. And what I'd like you to do is create a new Python 3 Jupyter notebook file. And it should look like that. So just give me a thumbs up if you are there with me, or if you need more time, just let us know on the chat. Great. Or use the reaction buttons that are on the top of the Teams bar, like this. Great. So I will assume that you have successfully created a new Jupyter notebook file in the same folder as your data. So let's go and rename this file lists, which is a topic for this chapter. And in this chapter, we're going to cover the reasons why programs need collections of values. And we're going to write some mini programs that create flat lists. It indexes them, it slices them, and modifies them through an assignment and method calls. And I will explain what that is if that sounds a bit tricky. So a list is an object in Python that stores multiple values in a single structure. For example, if you want to do some calculations and you have 100 different variables called pressure 1, pressure 2, etc., it would be really slow, not really efficient, and doing that by hand would be just a pain. So we can use a list to store multiple values together in one object in Python. They are contained in square brackets, and the values are separated by commas. And then you can use the length function that we learned yesterday to find out how many values we have in a list. So let's start by typing. So if you remember from yesterday when we type the hashtag symbol, everything that follows the hashtag symbol is not being processed by Python. It is a comment that helps you annotate your code and keep your documentation that explains your code. And it's not, it is completely ignored by Python. So let's create a new variable called pressures. And then when you create this new list, you need to use the square brackets. And let's populate this list with some values. So we have 0 to 73, 0 to 75, comma, 0 to 77, 0 to 75, and 0 to 76. So as you can see here, we create the new variable, but instead of allocating one value, we have allocated multiple values to it in a square bracket, and these values are separated by commas. So this object here is now a list. This is how we describe this object in Python. So if we print and say pressures, if we print this new variable and then inquire about the length of this object, of this list in particularly, then you'll see that we get all the values that are stored in the list that is associated with this variable, with the variable pressures. And then we get the length of the values that are stored in the list. In this case, we have 5 different values. Now, you can use an items index to fetch it from a list. Similarly, like we did yesterday, where we use the index location to retrieve some information from our data frame. So you can use that for lists as well. For example, if you say I want the 0th item of pressures, and as we mentioned yesterday, indices in Python start from 0 and not from 1. So the first value will have an index location of 0. There are some historical reasons behind that you can look online why that happens. But just think of it like how many steps you need to take to get somewhere. And then the 4th, there you go. So the 0th item of pressures, and that refers to the index location, the 0th, it's 0 to 73. As you can see, this is the first value of the list. And the 4th value that exists in the 4th corresponds to the 4th index is 0 to 76 because it's 0, 1, 2, 3, 4. And you can use an index expression on the left of assignment to replace a value. So if you say pressures 0 is now 0.265, this the value that exists on the first on the 0th index of this list is now replaced with this value. And if we check if that's the case, you can see that now the first value of the list is different because we just replaced it. So you can replace individual items within the list, individual values in this case, if you like. by calling the index location. Any questions so far? Oh, great. I'm going to turn off my camera because my laptop is a bit slow. Great. Right, so you can append items to a list. When you append items to a list, then the list is getting longer. So think of the append method as basically adding things to the list. So if you have 5 items in the list and then you append 3 more, you end up with a list of 8 items. So let's create a new variable called primes, and let's make it a list by opening the square brackets and populate it with these 3 values, 3, 2, 3, 5. Then if we say just print the values that are stored in the primes list, primes is initially and then let's append an extra value to it. So you can do that by using the append method. So methods, just a refresher, methods are functions that are attached to objects in Python. In this case, we attach the append function in the primes list. So when they are attached to objects, they're called methods. And let's print the new primes list. So when we execute this cell, you can see that our initial list has 3 values in it, 2, 3, and 5. And then after appending the number 7, now our list has 4 items, and we have the number 7 right at the end. Now, when you use the object name and then followed like a dot and then the method name, you can call the method the specific method that we are using, and it deliberately resembles the way that we refer to things in a library. Remember that you can always use the help function. For example, if you use help and then in parentheses the name of the list that you have created, then you'll get information about this specific object in Python. In this case, this tells us that this is a list object, and it gives you a little bit of information about it and some things that you can do with it. Comment this out. There you go. Now, let's create a new list called thin primes that equals to 11, 13, 17, and 19. And then we have the middle-aged primes that equals to 37, 41, 43, and 47. I don't know who named these variables. Right. So let's print and say primes is currently primes. So this will print the primes variable, the primes list that we created on the cell above. Then let's say that we want to extend this this list by adding the 10 primes to it. You can use the extend method to do that. So you can add lists to other lists. And say primes has now become primes. And you can further extend your list by appending another list to it. So you can say primes dot append middle-aged primes. And then you can print that, and let's see what happens. So when you execute that, you can see that we now have, we started with this primes list, the one that we have created here after appending the number 7 to it. Then after extending this list by adding the 10 primes, we have created a kind of larger list. And then by appending a different list, you can see we have a nested list within our list. So this is the main difference between extend and append. Extend is kind of extending your list and making it longer, and appending is kind of similar to that, but you basically add the whole thing as a whole. So you append the whole list as a list to your already existing list instead of taking the values and adding them to your existing list that extend does. Any questions so far? No? Great. Now you can, the same way you can append things to a list or extend a list, you can use the DEL to remove items from a list entirely, which stands for kind of delete them. And you can use it to remove an element from a list. You can use it by calling the index location of the specific element that you want to remove from a list. And del is not a function or method. It's more of a statement in the language. So let's say that we have, let's revalue the primes variable, and let's say that it is 2, 3, 5, 7, and 9. Let's print that and say primes before last item, which will print the list that we have created. And then let's use the del statement. And let's remove the value that corresponds to the 4th index location. In this case, it's 0, 1, 2, 3, 4. So that would be 9. And let's print and say primes after removing last item. And when you execute this cell, you can see that we started with this list, and then after deleting the element that corresponded to the 4th index location, we ended up with this list. Now, you might encounter an empty list sometimes, and an empty list looks like this. And an empty list on its own basically represents a list that doesn't contain any values. And it's really helpful as a starting point for collecting values. So you can say, I have like this empty list, and then after some calculations, this list will be populated by some specific values. So we're going to cover that in the next kind of chapter, the next episode. But you might encounter this as an empty list, but we'll do a couple of examples later on. Now, remember that a list may contain some values of different types. It's not necessary for a list to contain data of the same nature. For example, let's say goals, say 1, which is an integer, create lists, which is a string, then 2, extract items from lists, comma, 3, modify lists. So here we have a mixed list where we have integers and strings. And when you kind of print that, say print, you get all the items of the list as an output. And all the character strings can be indexed like the list. So you can get a single character from a character string using indices in square brackets, as we mentioned yesterday. So element equals carbon, say print element 0. This will retrieve the character that exists on the 0th index, which is in this case is the letter C. Now, character strings are immutable, which means that they cannot change after they've been created. In contrast, lists are mutable and they can be modified in place. So Python considers the string to be a single value with parts and not a collection of values. For example, if you say element 0 equals to a capital C, then you will get an error because the characters in a string cannot be changed, but the elements of a list can be changed. If you index beyond the end of the collection, then you will encounter an error, which is called an index error. So if you try to access a value that does not exist, for example, if you try to print the element object that exists on the 99th index location, then you'll get this error, an index error, because it says string index is out of range, which means that your character does not have that many elements in it, so you get the error. So let's do a short exercise. What I'd like you to do is fill in the blanks so that the program below produces the output zone. These are the blanks. I'm going to paste that into the collaborative document. And this is the output that you should get. I'm going to paste that in the collaborative document. I'm going to give you a few minutes to do that. Great. So does anyone have any suggestions of how we can solve this mini exercise? All right, so let's start with an empty list. And then in order to populate this list, we're going to use the append method. So we're going to append the number 1, append the number 3, and append the number 5. So when we print this list, we will get these three values, a list with 3 values. But then we want to remove one, in which case we say values equals values, but from the first index and on. When you run this cell, you'll see that we now only have two values. So you can use that and say, okay, our old list equals our list, but we want everything from the first index and on, which is this column refers to. So basically remove the value that exists on the 0th index. In this very small list, you could maybe replace it manually, but this is way more efficient. And when you have really long lists, this is an efficient way of doing it. If you know exactly which value you want to remove and the index location of that value, so you can either use the delete element or this way. So there are multiple ways in Python for doing the same thing, and there are multiple creative ways of doing it. So yeah, keeping that in mind. So let's do another sort exercise. Let's see. Let's do that. So I'm going to paste that into the collaborative document. There we go. So yeah, could someone tell me what this small program will print? Right, so let's execute that. And I will explain what that does. So when you have two two columns like this, the first one refers to the low, the middle one's the high, and the third number is the stride. So the law is similar to, to the slices that we used yesterday. You declare where you want your slice to start, in the middle where you want it to end. And the third number here, which is called the stride, is how many indices you want it to jump. So in this case, on the first one, our element is fluorine. And we say, I want you to basically print every second letter in this element. So it starts with F, which is the first one. It skips L, it prints the U, it skips O, it prints the R, and so on. If you put a negative number, then it will start from the end, basically. So it starts from E, N, I, and so on. So it basically prints the word from finish to start. So you can kind of declare, I want you to print that, but start from the end and go to the start. Do you have any questions? Is that clear? Yes, no? Yes? Great. Right, so this was kind of the introduction to lists and how we can use them. So now please go ahead and create a new notebook. Let's save and close the previous one. So if you go back to your directory here, you might notice that these have different color. If the color of this little notebook is green, it means that this notebook is still running, the kernel is still running. So if you want to save some memory on your computer, you can go ahead and click shut down. So only one notebook is running at the time. So let's replace the name, and we are going to move to for loops. So let's call it that. So for loops, if you're not familiar with for loops or programming, they might sound a bit confusing, but they're not as bad as they look. So in this chapter, we're going to explain what they are and how we use them. We're going to trace the execution of a simple loop and state the values of variables in its iteration, and write some for loops that use the accumulator pattern to aggregate some values. Now, a for loop executes commands once for each value in a collection, and you can do calculation on the values one by one, but this is not efficient. And the reason we are learning programming is to do things more efficiently than doing them by hand. So a for loop basically tells Python to execute some statements once for each value in a list, a character or some other collection. And for each thing in this group, please do these operations. And I will explain exactly what that is and how it works. So in order to create a for loop, we start with this special word for and say for number in 235 colon print number. And then you go outside of, there you go. So we have successfully created a for loop, and a for loop asks Python to iterate through the items that we give it and execute a specific operation. In this case, we say for number in this list. So this is kind of a placeholder. This is an alias. You could say for I in 235 print I, and it would work the same way. But it's this is, think of it like a variable name. It has to be meaningful. So give it a meaningful name. So what we call it is numbers, and we say for each number that exists in this list, please print the item that you find in this list. So it starts by printing the number 2, and then it restarts and it finds the second element and it prints it, and then it restarts and it finds the third element and it prints that. Does that make sense? So think of it like you execute this but instead of doing it by hand, a for loop is doing it for you. So it finds the element, it prints it, it finds the second element, it prints it, and then it goes and finds a third one. And when it doesn't find any other elements, it stops executing. Is that clear? Yes? No? Great. So for loops are really, really useful. They are very commonly used in Python because they make your program more efficient. So a for loop is made up of a kind of a collection of things, the loop variable and the body. So the collection in this case is this list here, which means this is where the for loop is executed on. The body is, in this case, the print function. And as you can see, this whatever exists within the for loop is intended. You need to always remember to add the colon at the end of the for loop. So 4 numbers in this list, colon, and then you add the body of the for loop. And then the loop variable, in this case, is its numbers. There you go. So number. So in this case, this is the loop variable. This is what changes for each iteration of the loop. Now, the first line of the for loop, as I mentioned, must end with a colon, and the body must always be intended. If that's not the case, if we restart our kernel and clear the output and execute that, we will get an error because we have created a for loop that has nothing in the body, so it doesn't do anything. And then we ask Python to print a number, but a number only exists within the for loop, and Python does not recognize it outside the for loop. And it tells you, if you read here, an indentation error that tells you that we expect an intended block. So Python is really smart, and because it knows that you have created the for loop and something needs to be in the body, but you have forgot to intend it or it's not intended. Now, keep in mind that indentation is always meaningful in Python. It is the same like in other, well, in multiple other languages. So if you type first name equals John, and then last name equals Smith, if you intend the second one, if you hit tab right at the beginning, you will get an indentation error. It tells you that there is an unexpected indent that's not supposed to be there. So keep that in mind, that in Python, indentation is meaningful. Now, as I mentioned earlier, these variables here, the loop variable that we have created, can be called anything you like. They can be like anything at all, like I showed previously with using the I letter. But as I said, please try, these are variables, and as we do with variables, we want to give them meaningful names, so they will make sense to other people reading our code, but most importantly to our future self when we revisit our code. Now, the body of a for loop can contain multiple statements, but usually it should be, it shouldn't be more than like a few lines. For example, let's create a new list that's called primes and populate it with some values. And then let's create a for loop and say for p in primes, it basically means for each element in this list, and then enter. I want you to execute this operation. So squared to cubed three, and let's print that. So we will print the number that it finds in the list and then the executed operations that followed. There you go. So now we have, as you can see here, we have the number it finds in the list, and then the squared result and the cubed result for that number, and so on. So you can have like multiple statements within a for loop, but try to keep them you know, concise. You can create as many for loops as you like within a program, but I would suggest to keep them clear and each loop to have a specific purpose and not populated with multiple things that are not connected, because that, you know, that will confuse you in the future, or you might get an error, not necessarily a Python error, but maybe a logical error if the for loop is not executed correctly or in the correct order. But you can also use range to iterate over a sequence of numbers. So range is a built-in function in Python, and it produces a sequence of numbers. And range n is the numbers 0, so range, and then parenthesis n, it's the numbers from 0 to n minus 1, if you are familiar with that. So which is like exactly the legal indices for a list or character strings of n length, basically. So let's start by printing a range is not a list. There you go. And let's create a for loop and say for number in range 0, 3, and always add a colon, print number. So yeah, keep in mind that the range is not a list. We just defined basically a range of numbers. This particular one starts from 0 and goes up to the value just before 0. So keep that in mind. So this is inclusive and this is exclusive. So this is 1 and this is 3 minus 1. So it goes up to 2, as you can see here, 0, 1, 2. But it's very helpful if you want to use you know, some numbers that are produced on demand, and they make looping over large ranges more efficient. Now, we mentioned the accumulator pattern at the beginning, and I will explain what that is. So an accumulator, you can initialize an accumulated variable to 0, the empty string or the empty list, and then update this variable with values from a collection. So we mentioned in the previous chapter the empty list, but you can create a list that looks like this, and you can later on populate it with some values. So let's start by typing the sum of the first 10 integers. So this is a comment. This won't be executed. There you go. And let's create a new variable called total that equals to 0. And let's create a for loop and say, so for number in the range of 10, so from 0 to 9, colon, say total equals to total plus the number plus 1. And then if you go outside of the for loop, go outside and say print the total, this will give you the number 55. So we'll explain why that is and how that happens. If you keep the print within the loop, it will show you the whole process. If you put the print outside of the loop, it will print the last operation. So let's go back and see how that works and break it down. So here we have a variable with a value of 0. And then here we have a range which starts from 0 to 9. And what we ask Python to do here is say we have the total. So we have this variable, and we want this variable to have this, to replace the value of this variable with this new value, which is the old value plus the number that it finds in the range plus 1. So the range starts from 0 and goes up to 9. So in this case, we start with 0. We say total equals 0 plus 0 plus 1, which is the first number here. And for the second number, which is 1, we say 1 plus 1 plus 1, it's 3. And now our total has the value of 3. So we move to the next one, which is the number 2. So we say 3 plus 2 plus 1, it's 6, and so on. So you can see that our last value is 55. So when you put the print function outside of the loop, it will only print the last value. That is the result of this for loop. So it goes through the range of these 10 numbers from 0 to 9. And then the for loop it exits the for loop. Python exits the for loop, and it prints the final result, which is 55. So do we have any questions so far? Is it clear? Yes? Great. Now, let's do a couple of exercises to kind of to practice a bit the new knowledge that we acquired in this chapter about for loops. So let's see.
Hi, sorry.
Yes.
Could you repeat how you put it outside the inside the loop to actually get the values as it's generating the values?
Yeah. So so if you print if you put the print within the for loop, then it will print. Then the print is part of the for loop. So the for loop does its thing, and then it prints the result. every time it goes through the loop. So here we have a range of 10, which is basically starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the range that we're using in this particular for loop. And we say for each element in this range, execute this operation. So our total has the value of 0 at the beginning. So we start with 0 plus 0, which is the first number in this range, plus 1, it gives us this number, and so on. When you put the print within the for loop, then you will get each operation as it goes through the for loop. But if you put the print outside the for loop, which means it is not intended, that is how you put it outside the loop. You break kind of everything that it is intended after the loop, then it is executed within the for loop. But if it's not intended, then it is executed outside the loop. So Python goes through that, and it kind of updates the value of total every time. So by the end of the for loop, after it has executed the last one, which is the result of the previous loop plus 9 plus 1, in which case this is 55, then Python will only print the last operation, because this is the last updated value of total after the executing this loop. Does that make sense?
Yes, no, sorry, I was getting an indentation error. I think it's because of the where the print was. So I thought I was doing something important, but that's fine. Thanks.
Okay, great. Yes, I'm just checking the chat. It says that yes, an extra space before print will yield full total single value as it's been treating outside for the loop. Yes. The spacing indentation is deciding. Yes, great. Yeah, so this is the kind of the deciding factor is indentation. So if it is intended, it is within the for loop. If it's not, then it's executing outside the for loop. So if you copy that and paste it right after the total, then you see here that before executing the for loop, the total has the value of 0. After executing the loop, then total has the value of 55. So you have 0 at the beginning, and then you have the loop that goes through all these numbers. And at the end of the loop, your total has now this updated value. Now let's do a short exercise. And yeah, keep in mind that there are multiple exercises in the link that I sent you about the course materials, and you can do them to practice on your own time. So let's try and solve this little exercise. So you have this list of word lengths, red, green, blue, and their length, which is 3, 5, and 4. And I want you to kind of fill in the blanks. Right, so do we have any suggestions? This might be a bit tricky. No? Okay, let's solve that. So let's start with an empty list. So say the length equal to an empty list. And then we say that for each word in this list, we basically want to append the length of each word. So we use the len function and then the word, which is the loop variable here. So what that does, if you execute that, we started with an empty list and then we create a for loop that goes through these three elements in this list. And we say that we want to use the append method in the length variable here. So we want to append the length of the word for each word in this list. So we start with 3. It finds the first word here. It calculates the length of this word, which is 3. Then it goes to the second one, which is 5. And it goes through the third one, which is 4. And each time it adds this value into this empty list that we created at the beginning. So if you put this print within the loop, you see that it starts by adding the number 3, which is the length of the first word. Then it adds 5, which is the length of the second word, and then at the end it adds 4. So this is the final list that you have. It is what is printed when it's outside the loop. Do we have any questions so far? No? Okay, great. So let's save this file and let's create a new Python notebook. And after this chapter, we are going to have our coffee break. So this next chapter is called conditionals. So let's rename this notebook as such. Let's rename that. So in this chapter, we will discuss how we can write programs correctly that use if and else statements. If you are familiar with that, if you're not, we will discuss that and explain what that is, and how to use simple Boolean expressions. And also we're going to learn how we can trace the execution of unnested conditionals and conditionals inside loops. So if and else, these two words are special words in Python, and you can tell because they have like this green color in this notebook. So if statements can be used in order to control whether or not a block of code is executed. So like in the natural language, we say if, let's say we have no eggs, then buy eggs. Else, do not buy eggs, basically. So this if statement, which is called a conditional statement, controls whether a block of code is executed or not. And it has a similar structure to a for statement. For example, we start by saying, let's create a new variable called mass, and the mass is 3.54, excuse me. So they're structured similarly like for loops. We say if mass is larger than 3, and we end the if statement with a colon, then print mass is large. So when you execute this, if this condition is correct, then we will print this, the value of the mass, and then followed by this statement that we added in our print function. So in this case, the value is indeed over 3. So it says that 3.54 is large. Now, if you say that our mass has now the value of 2.07, and then you repeat, copy and paste that if conditional, nothing will get printed because this condition is not true. So this piece of code is not executed. The code that is within the if conditional. If you put the print outside the if conditional, then you will get an indentation error because Python is smart enough to realize that you have created an if conditional. You have an if statement here, and you're expected to have an indentation and something within the if statement. So it tells you that we expect this to have a body, like the for loop. If statements have bodies as well. So here is the how we initiate our statement. We use the special word if, and then we have the variable, which is mass, in this case 3.54, and the second case 2.07, and we say if it is larger than 3, then print the value, and then it's large. But if it's less than 3, then print nothing. Now, conditionals are often used inside loops. For example, let's create a new variable that's called masses, and this variable will hold a list, and this list will have these values. So 3.54, 2.07, 9.22, 1.86, and 1.71. And then let's create a for loop. So for m, which is the loop variable, in masses, colon, indentation, and then say if m, which stands for the values in masses, if m is larger than 3, then colon, another indentation, then print m, and then followed by is large. So the for loop will go through all the values in the list that we created and see if the value is larger than 3, then this value is printed. If it's not, then it's not printed. Now, you can use else to execute a block of code when an if condition is not true. So in this case, we can say, okay, for m in masses, if m is larger than 3, then print all the values that are larger than 3. Else, colon, print m is small. In which case you'll have this output here, where all the values that are over 3 again get printed and then followed by is large, and all the values that are smaller than 3 are followed by is small. Now there is another one that is called elif, which means else if, that you can use in order to specify additional tests. And these are always associated with an if statement, and they must always come before the else statement. So think of the else statement as the last result, the one that will catch the rest, that all filter through if and elif. So let's add a new line here and say, okay, if m is larger than 9, then print the number, and then it is huge, and then else if m is larger than 3, then say m is large, And of course, the last one, if this does not fall into these two categories, then print it small. So this is kind of just print the rest that are outside these conditions. So when you execute that, you see that the value that is over 9, which is this one, it's followed by suits, and then it goes through the list again and say, okay, now find all the values that are larger than 3, and then it prints those, and at the end, it prints the rest that followed by is small. Do we have any questions so far? No? Great. So keep in mind that conditions are tested once and in order. So Python steps through the branches of the conditional in order, and it's testing it in turn. So the order that you execute things matters. For example, if you say grade equals 285, and then if grade is larger or equal to 70, then print grade is C. Else, if grade is larger or equal to 80, print grade is B. Else, if grade is larger or equal to 90, print grade is A. Now, if you execute this, you will get a grade is C because you have a grade of 85 and you say, okay, if the grade is larger than 70, then print this and stop executing the rest of the conditional, which in this case, it's true. The value is larger than 70, so the first condition is true, so it doesn't follow up with the rest. So keep in mind that the order is important. The order of execution is important. So if you put this instead of 70 here, and here instead of 70, you have that, then you will get the correct answer, which is the grade is B, which is within this range of 80-90. Now, keep in mind that it does not automatically go back and reevaluate if the values change. So when we say that the velocity equals to 10, and if the velocity is larger than 20, print moving too fast, else print adjusting velocity. And you say the velocity equals to 50. So when you execute this, it will say that we are adjusting the velocity because it does not automatically go back to reevaluate if the values change. So we've changed the value of velocity right at the end of this conditional. So when the value at the beginning is 10, then this first condition is not true. Then this condition is true, but then we change the value of velocity, of the velocity variable right at the end. So it doesn't really go back and loop through. It doesn't work like the for loops. It executes in order. If the first one is true, it stops executing the rest of the code. If it's not, then it continues. And then now if we print the velocity, now the velocity has the value of 50, but it has the new value right after we executed the conditional. As we mentioned earlier, we use conditionals in loops in order to evolve the values of variables. So let's say that the velocity equals to 10. So let's create a new for loop and say for I in range 5. Which means that we execute the loop 5 times. Print I, which is the loop conditional, followed by this symbol here, and then the velocity. And say if velocity is larger than 20, then print moving too fast. And we want the velocity to reduce by 5. There you go. Else, print moving too slow. In which case we want to increase the velocity by 5 or by 10. C plus 10. And then outside of this for loop, we want to print the final result, which is final velocity. So would anyone like to tell me what the final result will be? So yeah, I think that this is going, this loop is executed 5 times. And our initial velocity is 10. So what will the final velocity be? Does anyone have any idea how this will work? Right, so our first, the initial value of velocity is 10. So we start going through the for loop. So it's 10. If the velocity is larger than 20, then we detract 5. It is, if this is not the case, then we add 10 to it. So in this case, we will add 10. So now we have a value of 20. So we're going through the for loop for the second time. And the value is 20, so it doesn't change. It says that we're moving too slow. And then we go through the loop for the third time, we add 10. So now our velocity is 30, in which case now the velocity is over 20, so we detract 5. So now we have velocity of 25, which is still moving too fast when you go through the for loop for the 4th time. So we detract 5 more. And when we go through the for loop for the last time, because the value is now 20 and it's not larger than 20, if that was larger or equal to 20, that would change, but it has to be larger than 20. Because the 5th time that we go through the for loop, our velocity has the value of 20, we will add 10 more. So the last value of velocity will be 30, which we can see here. So we go through it once, it's moving too slow, we add 10, it's still moving too slow, we add 10, then it's moving too fast, we detract 5, it's still moving too fast, we detract 5, and the last time it is moving too slow and we add 10. Does that make sense, or do we have any question? That's great. Yes, 30. Great. Now, we can create a table showing variables values to trace a program's execution. For example, let's say mass equals to 3.54, 2.05, 9.22, 1.86, and 1.71. So this is one list. And then we can create another list that has the following values: 10, 20, 30, 40, 25, and 20. So we have these two lists, and we will create this new element, this new variable, the variable I that equals to 0. And then we are going to create a for loop, and we are going to say that for I in range 5, which means that this for loop will be executed 5 times, if mass of I is larger than 5 and velocity of I is larger than 20, colon, print fast heavy object, tag. Then we go outside this if conditional and say else if the mass of I is larger than 2 and the mass of I is smaller or equal to 5 and the velocity of I is smaller or equal to 20, then print normal traffic. Else, if the mass of I is smaller or equal to 2 and the velocity of I is smaller or equal to 20, then print slow light object, ignore it. And to catch the rest, we add an else statement and say print something is up with the data. Check it. Because we expect everything to fall in within these categories. So when we execute that, we say that, okay, we start with the mass and the velocity with the first, when it goes through this for loop 5 times and use these values, then you see that we start by saying something is up with the data, check it, and then the traffic is normal, and then something is up with the data, something is up with the data, and then slow light object ignore. So you can use a combination of things that can be true. You can combine the relations within a conditional using and or. So yeah, it's basically just like arithmetic. Like with arithmetic, you can and you can use parentheses whenever you have an ambiguity. And this is a good general rule to always use parentheses when mixing and or in the same condition, instead of having one large line with and or conditions. So it's perfectly clear to you and the reader and Python as well. Now we'll do a short exercise and then we'll have our coffee break. And okay, say fill in the blanks. This is the exercise, so copy and paste that. Just comment this out and this one. So I'll give you a few minutes to do that, and then we can go on our coffee break. This is the output that you should aim for, this bit here. Do you have any suggestions of how can we fill in the blanks in this example? Great, so let's see, we have one here. So let's add a new cell and see if that works. Great, so this is indeed the correct way of doing it. Yeah. Yes, exactly. So we start with an empty list, and then we say if the value is smaller than 0, then append 0, else append 1. And this is kind of the result that we get. Great. So indeed, this is how you solve this sort exercise. So we are ready. Let's go on our coffee break for around 15 minutes and get back at around 12 to continue. And then we'll have our lunch break later on. So yes, see you at around 12 UK time. I'm not sure in which time zone you are, so 15 minutes from now, I would say. So see you in a bit. Hello, welcome back. Just give me an indication that you're back from the break. Great. Great, thank you. Right, so let's continue with the next chapter. So we'll do the same thing that we've done so many times and create a new Python notebook. Let's close these two. Right, so the next chapter after conditionals is looping over datasets. So that is the name that we're going to give to this file. There you go. Now, in this chapter, we are going to talk about how we can read and write globbing expressions that match sets of files, and we will explain what that means. Use glob to create lists of files, and then write for loops to perform operations on files given their names in a list. Now, we talked about for loops and how we can use for loops to iterate through items like lists or ranges, but we might want to iterate through files or process files, given a list of their names, for example. Now, in order to do that, we need to import pandas, and we import pandas as PD. And then we're going to create a for loop and say for file name in data / gapminder GDP _ Africa dot CSV comma data / gapminder _ GDP _ Asia .csv, and we need to add quotes here. There you go. So for this list, we want to create a new variable called data, which equals to pandas.read _ CSV, and then the file name, which is the loop variable that we have created here, comma index _ call equals country, and then print file name and the minimum of the data. The minimum value found in this data. There you go. So what that does here, we asked Python to read these two CSVs. So in this case, we have two files. We have the Gapminder for Africa and the Gapminder for Asia. And we ask Python to iterate through the contents of these two CSV files, which is what we did here. We want to read these files and index the files by using the country column as the index. And then we want to print the name of the file and then the minimum that is found in the data, which is this variable we created here. Excuse me, Dana, you're in mute. Apologies for the disruption. Right. So what that does is it's going through the elements of these files. If you remember from yesterday, these files contain the GDP per capita for specific years, for different continents. In this case, we're using Africa and Asia data. And then it prints the minimum value for each year for both these files. So here it goes through Africa first. It prints the minimum value for the year 1957, all the way up to 2007, and then it goes through the second file, which is the GDP per capita for Asia, and does the same thing. So it prints the minimum value for each year. Now, you can use glob to find sets of files whose names match a specific pattern. So globbing is a Unix term, and it means matching a set of files with a pattern. The most common patterns are the asterisk, which means match 0 or more characters, and the question mark, which means match exactly one character. And we will do a couple of examples to explain a bit further. So the glob module contains a function that it's also called glob to match file patterns. An example would be glob.glob, and then in the parentheses we say asterisk.txt, which will fetch all the files that are a txt that have the txt file extension, no matter what their name is, because it will fetch everything, which that asterisk means. And it can result. It will result in a list that could possibly be empty if nothing matches the criterion that we put, and a list of character strings. So we start by importing glob, the module glob, and then we say print all CSV files in the data directory. And then comma. In order to do that, we say from the glob module, use the glob function and fetch all the data files that you can find in the data folder with an extension CSV. And this will give us a kind of list of all the names of the files that we have in this folder, in this directory. In this case, we have Gapminder all, and then Gapminder for all the continents. Now you can also say print in the parentheses all PDB files, and then from the glob module, use the glob function and fetch all the files with an extension of PDB. You can see that the result is an empty list because in this particular kind of directory, we don't have any files with this extension. Now you can use both glob and for to process batches of files, and that helps with where if the files are named and stored systematically and consistently, so you can find simple patterns. For example, you can say, let's create a for loop. So for file name in glob data gapminder underscore and then asterisk. So basically fetch all the files that have gapminder underscore and then something in their file name, and followed by the extension CSV. And because it is a for loop, we finish the first line with the colon and say, okay, our data is read CSV and then parentheses, file name, then print the file name, and then data, PDB per cap underscore 1952, followed by min. So in this case, it's gonna go through all of the files that start with gapminder underscore something.csv, and then it's going to create a new variable called data. In this variable, it's going to store the data for each file that matches this criterion here. And for each of these files, we're gonna print the file name and then the minimum value for the year 1952, if this exists within our data. So if you execute this cell, you can see that for gapminder all, this is the minimum value for that year. For gapminder Africa, this is the minimum value for that year. For America is this one, Asia this one, Europe, Oceania, and so on. So do we have any questions so far? Okay, yeah. Yes, so yeah, that's a good tip. You can press the tab key inside the quotes if you want to autocomplete the path. So no questions so far. So let's go and do a short exercise. Right, so what I'd like you to do, I will add this here. So this is the exercise. So I'd like you to modify this program here so that it prints the numbers of records in the file that has the fewest records. So we were importing the glob module and the pandas library, and we start by fewest equals something. And for the file name in this directory, so all the files with this extension in the data folder, you want to, again, yeah. We want to print the smaller file with the fewest records.
Then there is a question in the chat for you.
Yes, so if I want to append all the data from CSV to the same data variable, how should I modify what you just showed us? So you basically want to create a new variable that holds all the data from all the CSV files? Is that what you mean?
Hi, Yutana. If you don't mind, could you speak up? You can speak to the question. Thank you.
Yeah, hopefully if that's what we mean. Anadi added a very helpful link, which is here, how you can append CSV files with pandas. There are a few ways of doing it. There are actually 3 ways in pandas, and it depends on your data and what types of data each file contains. So there is like concat, there is join and merge. There are 3 ways of doing that. But yeah, if you want to learn a bit more about that, this example uses concat, I think. Yeah, it uses concat, which is a method that combines a list of pandas data frames into one data frame. But you can also merge or join your data. Each of these 3 things basically merges your files into one in different ways. Right, so let's solve this short exercise. So we have imported these 2 modules, Globe and Pandas, and the library Pandas. So we start by saying our fewest is going to be a float. So for the file names in this directory that have this file extension, we can read this file. So we use the read CSV method. And in order to get the fewest, we say fewest equals with the minimum of the fewest and the shape of the data frame. So we print the smallest file has this amount of records. So if we print that, we'll see that the smallest file has 2 records. If you remember from yesterday, Oceania's data file only hold two records, one for Australia and one for New Zealand. So I assume this is the one that it refers to. So we start by creating the fewest variable and then going through the for loop. And it goes through all our data. It reads our CSV data, and then it prints the one with the fewest records, and then the shape of that data frame, which in this case is 2. So let's also do this exercise and see. So which of these files is not matched by the expression globe? So if you could type that on the chat, just add that here. I will make this a markdown cell. So we have these 3. So please type which one of these 3 is not matched by this expression. Which is as. So this is the one. So we have one answer. Now, it's not America, it's Americas. It's the Americas. So the correct answer is Africa, because it could either start with AS or find the sequence of letters anywhere in the name. It doesn't matter. So the asterisk means one or more follow, or one or zero or more follow, or 0 or more are before this sequence of letters. So in Africa, we don't have this sequence of letters. In Americas, it's right here at the end. In Asia, it's here at the beginning. So Africa is the correct answer. Great. So let's save this file and let's create a new notebook. Okay, we have a question. Yeah, okay, so yeah. The float inf, as Anajat mentions, it's the keyword that can be used to initialize a variable with an infinite value, rather than relying on an arbitrary large number. Yeah. Exactly, so that's yeah. So in this case, it's kind of returns a floating point positive infinity, basically. So yeah, this might be a good example. There you go. So this, the Python Infinity, the float it was a bit more advanced. So if you know it, but it makes things a bit more efficient. Right. So let's move to the next bit, which is writing functions. And let's rename that. So in this episode, we are going to explain and identify the difference between function definition and function call. And we are going to write some functions that takes a small number of arguments and produces a single result. Now, it is a good practice to kind of break bigger programs into functions to make them a bit easier and more manageable. We call that in computational thinking, we call that decomposition, where you have a big problem and you break it down into smaller bits. So that's what functions do. There are small programs within the program that execute bits of code, and they are kind of memory efficient within your code. So in order to understand like larger complicated ideas, we can add these as components, and functions serve like the same purpose in programs. So they encapsulate complexity so that we can treat it as a single thing. And we can also reuse them later on if you like. So they're kind of, think of it like programs within your program, like code blocks within your code that you can reuse. So in order to create a function, we use the special keyword def. And we add a name and parameters and then the block of code.
Sorry to interrupt. You have a request for lunch break timing?
Yes, let's see. Yeah, so the lunch break will be at around 1:15, approximately, if that's okay. Great. So, right. So let's start by, yeah. So we have the special keyword def, and then let's create an example. Let's say greeting, and then it's very similar in structure, like the conditionals and the for loops. It means that you create the function and then you add a colon and the body of the function is intended. And say hello. The weather is nice today. Right? There you go. So we have created this small program and says print greeting, print hello, print the weather is nice today, print right. Okay. So now in this example, we have the name of the function, which is, in this case, it's print greeting. And then we have an empty parenthesis if the function doesn't take any inputs. In this case, it doesn't. And we will discuss that in a few seconds. And then we have the colon. And then we have the intended block of code. Now, defining a function does not run the function. It's not the same as for loops or conditionals, right? If you say, if you want to kind of execute this function, think of it like assigning a value to a variable. So you create this block, but you need to call it in order to execute. So this is the name of our function. So this is what we need to use in order to call it. So if you say print greeting, and you execute that, then it will execute this block of code that is associated with this function. So it will say, hello, the weather is nice today, right? Now, you can reuse that as many times as you like throughout your notebook or your code, because this is kind of a definition. You defined this code. You create this small program within your program, and you can reuse it as many times as you like. Now, arguments in a function call are matched to its defined parameters. They are most useful, functions are most useful when they can operate on different data, and we specify the parameters when we define the function, like we did here. We don't have any parameters in this case. Now, let's create an example and say def print the date. And then within the parentheses is where we specify the parameters of the function. Say year, month, day, followed by colon, and then in the intended part we add the code block and say joint equals string for year plus this symbol here. As the string for month. So remember from yesterday that even though this might be numerical for the year and the day, for example, in this case, they're all strings because that's how we define them. Say string for day, then print joint. So now we have created this function where we get these parameters, these three parameters that we specified here, and we join them into one big string. So if we want to print date for 1971/3/19, this function expects three parameters because we have three items within this parentheses. So we need to give it three values to use. Now you can see that we specified three numerical values. In this case, we have three integers. But what this program does is converting them into a string and then kind of joining all the numbers together into one with this separator here. So when you execute this, so you can see that here we use the name of the function here. When you execute that, this is the result that you get. So these are the parameters, as I mentioned. You need to specify as many parameters as you create in your function. If you had less than that, you will get an error because it's if you see here, it's a type error and it tells you that the print date function is missing one required positional argument, this one. So we have the first two, but I'm missing one and I cannot execute this piece of code without it. So we can name the arguments when we call the function. For example, if you say print underscore date and then say month equals 3 and day equals 19 and year equals 1871. It will still work because here it doesn't matter if they're in the wrong order, because we kind of specified which is the corresponding number for each. So the number 3 corresponds to this parameter, number 19 corresponds to this parameter, and this number corresponds to this parameter. Now, functions may return a result to their code using using return. For example, let's create a new function called average, and let's pass one parameter that's called values, and say that if the length of values is exactly equal to 0, which this double equal sign means. So when we use a single equal sign is how we assign things in Python, but when you use a double equal sign is to specify that this is the exact value that we expect. So when we say if the length of values is exactly equal to 0, then return none. And return the sum of values divided by the length of values. So we have created this function here. So when we say A equals average, then in parentheses we create a list 1, 3, 4. We say print the average of actual values A, and you execute that. Okay, name average is not defined. A typo here. So it tells you that the average of actual values is 2.666 and so on. So this is our function name. And when we call it, it understands that the average holds these values. In this case, this is a list. And the reason it is within these parentheses is because this is the function that we created, and it expects some values to be passed on. And in this case, we passed a whole list. So it expects one parameter. And here, even though we have 3 numbers, we have one parameter, and our parameter is one list. And it prints the average of actual values. So it goes through each of those values and returns the sum of the values divided by the length of the values. So the sum is 8 divided by 3 gives you this number here. Do you have any questions so far? No? Okay. Right, so yeah, so let's do another example where we say print the average of empty list. Then this will return none because there is nothing passed as a parameter for this function to use here. So we have exactly 0, so it returns this kind of special word used in Python, none. Now remember that every function returns something. And if it doesn't explicitly return a value, it will automatically return none. For example, if your result equals to print date, which is the previous function that we created, 1871, 3, and 19. If you print the result, well, is none. Because if, yeah, this is not, yeah, the function will not explicitly return a value because it's kind of, we have a variable and then you have this assigned to this variable, so you will get none. Now let's do a couple of exercises. Right, so what I'd like you to do is I want you to read this code below, and I will do a better job presenting that. Okay. There you go. So you have one indentation. There you go. So read this code below and tell me in the chat if you can identify what the errors are without running it, and then run the code and read the error messages. And then hopefully fix it and let me know how that works. Okay, so let's see. Does anyone, from the average function, can we format the output of average, for example, to print two-digit numbers? This one, if we format the output of average, I'm not sure what you mean by that. So the average expects an input, in this case, exactly 1. So depending on what values you're going to give it, that's what you're gonna get when this code is executed. But I'm not sure what you mean by 2-digit numbers. Do you mean like floats, floating number point numbers? So if you use 1.5 and 3.7 and 4.8, when you execute this is what you get. But do you mean the output here, just to contain only maybe 1 or 2 digits? Is that what you mean? I mean, like only it contained 2 decimal points. Yeah, so this is, yeah, it's. So let's solve this one and we'll go back to the question. I think that's what you mean, like only output only maybe 1 or 2 decimal points. So yes, this is the first error we get in this example is a syntax error, because remember that functions just like conditionals and for loops expect a colon at the end. So this is one mistake. So if we rerun that, then we still get an invalid syntax because we need to also add these parentheses, which is the parameters. You can have 0 to as many as you like. So when you do that, you don't have a syntax error anymore, but we have an indentation error because there is an unexpected indent. So you need to fix that. And you can do that just like that. So now our code is fixed. So going back to the question that we had in the chat, Idana asked for this function here, because we get an output of kind of a long number. If we can format the output of the average to only print 1 or 2, or maybe 1 or 2 decimal places, if I understood that correctly. So this is an example that Anna put in the chat. So you can do that by, so you have like a float number that has like multiple decimals, and we only need 1 or 2. So you can specify how many decimal places that you like. In this case, we say, okay, what I like Python to do is just have the full number, and whatever follows after the dot, just keep 2 decimal places. And when we print that, you can see that only 2 are shown instead of the really large number. Great. Right, so because we're running a bit late, let's save this one. And you can always go back to these materials here, and there are some other exercises that you can do right at the end of each chapter, so you can do them on your own time. So let's move to the next one, which is variable scope, and this is the last chapter before our lunch break. So let's create a new notebook. and rename this notebook variable scope. And in this chapter, we are going to identify some local and some global variables, some parameters as local variables, and read a traceback and determine the file function and line number on which the error occurred, the type of error, and the error methods. Now, the scope of a variable is a part of a program that can see that variable. So, for example, let's say pressure is 103.9. And let's create a new function that's called adjust, that takes one parameter, the parameter t. Say temperature equals to t times 1.43 pressure, and return the temperature. There you go. Now, if we move outside of our function, let's execute this cell actually. So now we have defined this function, we have the pressure, we have the function name, we have our code block here. Now, remember that pressure, because it exists outside of this function, this is a global variable that we can call throughout our code. But T, which is this one, and temperature are local variables. And they are local variables within the adjust function, which means that if we say print T, we will get an error because name T is not defined. If you say print T within the function, well, not here, we need to call it. So if the temperature, if we say print, you will get the same error because temperature and T are local variables that only exist within this function. If you, however, try to print pressure, you'll get the number that we defined here. Now, T and temperature, as I mentioned, are local variables. They are defined in the function. They're not visible in the main program. And a function parameter is a variable that is automatically assigned a value when the function is called. If you don't call the function, then this variable is not assigned with anything, so it doesn't really execute this piece of code. So for example, if we say adjusted and then use the adjust function, which is this one, and in the parentheses we give it a variable 0.9, then this function will get executed. Temperature after call. The same temperature is not defined. Okay. So you get these, the adjusted here is the value that you get because you pass this parameter into our function, and then this function used this value to do this calculation here. But then we try to print this temperature variable outside of this function, and this is why we get this name error that says that temperature is not defined because temperature only exists within the function. Now, let's actually do a bit more. Right, so let's do a couple of exercises. Let's do the first one. So this is the local and the global variable use. So I will give you a few minutes to do that. You need to trace all the values of all variables in this program as it is executed, and you can use dash as the value of variables before and after they exist. So have you worked through that? So this is kind of a practice exercise, so you can play around with the values and to understand the how functions work and a bit about the local and the global variables and how they're used. Now let's actually, I would suggest to go on our lunch break now and then come back and continue with the rest of the workshop, if you're okay with that. And yeah, let's meet back in around 30 minutes, sorry. So see you back at 1:30 if you are in the UK, or in 30 minutes from now. See you in a bit. Welcome back. Just wait for a couple of minutes for people to get back from their break. If you could show me a thumbs up to see if you're back, that would be great. Amazing, great. So now that you're back, let me share my screen again. So today we talked about lists and for loops and conditionals, and how we can loop over data sets, and how we can write some functions, and what types of different variables we have in Python, like the local and the global variables. But it is also really important to talk about efficiency and effectiveness when we're writing in Python and our programming style. So one of the cornerstones of Python and in programming in general is how readable our code is, and or how consistent and how efficient our coding style is. Now, a consistent coding style can help you, your future self, and other people to read and understand your code more easily. And there are some kind of suggestions and some standards that exist for Python for the coding style. And one of these kind of standards is the PP8, which is a style guide for Python code. So I would suggest you go, you follow the link. I'm going to paste this link in the chat. And in the collaborative document. There you go. So this is a style guide when you're writing Python. There are different things. It's quite extensive. We cannot really go through the whole thing today. But there are some suggestions that are nice to be followed when you're programming in Python. Efficiency is one, as I mentioned, one of the cornerstones of good coding practice. It is one of the criteria that we mark our students on, how efficient and how effective the code is. So it is super important, and it's a good practice. So I would suggest to go through this document. There are some other suggestions as well. So you have the PP8, which is a style guide for Python, as I mentioned. You can check if your code is compliant with PP8 by using the PyCode style application, which is, let me open that in a new tab, which is this one here. So you can install it just like you install other libraries. And you can use it to check if your Python code is compliant with the PP8 standard. There are some examples that you can kind of run and understand how this works. So let's find some examples, demonstrate how that works. So if we go back to our notebook and create a new Python notebook and rename it coding style. When you, let's say that you define a new function that it's called parse argument, so arg string, then you can pass this this piece of code here that actually checks for your if your code is compliant with the PP standard. So there are a few examples that you can use. You can check other resources as well. So we have that. We have another tool that's called Black Code Formatter that can automatically format your code to conform with the PEP8 standard. There are some other ways, some other Python styles that you can use. One of them is the Google Style Guide on Python, which is this one. You can find all the links, by the way, in the under programming style in the workshop resource page. So the Google Style Guide on Python is a slightly different style for Python, slightly different than the P8. And then Google wrote an application that can help you conform with their suggested Python style, which is called YAP, which is this one here. So if you're familiar with GitHub and how to use it, you can read the documentation on this. You can install it and start using it if you prefer using the Google Style Guide on Python. Now, you can also use assertions to check for internal errors. For example, you can make sure in this example that the method, you can make sure that the context in which your code is executing is as you expect. And you can also use docstrings to provide built-in help. So you can go through this on your own time and kind of decide which style is better for you. But the key, remember, the key for writing code in general and Python more specifically that we used in this workshop is consistency. So decide on a style and then use that consistently throughout your code. That will help you to better understand your code when you're visiting, and for other people to understand your code when you're giving them the documentation and tell them I followed this Python style to kind of format my code. So yeah, I would suggest you go and read this chapter of the course. And because you were such good students today, we are actually finished a bit earlier. So what we can do now is, what I would like you to do is to give us some feedback and maybe discuss today's workshop. And yeah, if you're happy to unmute and maybe kind of discuss which things worked better and which parts you would like for us to work on a bit more, or if you have any questions, that would be the time to discuss that. So yeah, feel free to unmute your microphone or type your questions or your recommendations or what you liked about the workshop. Here in the course kind of resources, you can find some very useful links about Python as well, such as the Python 3 documentation that tell you all about Python 3.11, which is the kind of the latest version iteration of Python. Then you have the PyCon, which is the largest annual Python programming language conference. If you're interested, you can follow their kind of activities and their events. We also have the SciPy, which is a rich collection of scientific utilities. So yeah, you can read the documentation for SciPy that provides fundamental algorithms for scientific computing in Python. You can see documentation. There is also a community that is very active, so you can join their meetings and so on. And we also have Jupyter, which is the home of the project Jupyter. Jupyter is the notebook that we used throughout this workshop. Pandas is the home of the Pandas data library. And you can find all the documentation for this library. And then you can find several sections on Stack Overflow. Python has a very active community, so you can ask for help, and they will be very happy to assist you. So yeah, if you don't have any feedback, I have one more kind of short exercise, or not exercise, kind of activity for you. So let me fetch that. So I'm gonna share this link for a Mentimeter activity in the chat and here. There you go. So click on this button right at the right corner at the bottom to indicate that you're here with me. You were able to access the link. So we're expecting 2 more people. Great. Right, so let's begin. So this has a form of a quiz because this is a free Mentimeter account. So even though it looks like a quiz, you're all winners. You will all get rewarded, and there are no right answers. So yeah, please tell me what was the most useful part of this workshop. Great. So we have some answers about the Python review, the matplot library, and plotting to people like that. The second day activities. Yeah, today we kind of dived into more advanced Python stuff. The live coding, that is great. I'm really happy to hear that because this is how I teach Python to students at the university as well, and they find it very, very useful to code along with me. You learn a bit, I believe that you learn a bit more and faster. Q&A, systematically cover all the essentials about Python. Great, thank you. So let's move to the next one. How would you rate today's workshop? Great. Thank you for the feedback. So let's move to the next question, which is if you have anything you wish we talked about more or less. Great, thank you very much. So we have, you want to spend a bit more time on functions, different graph formats, and NumPy. Yeah, unfortunately, this particular workshop, they're all created by the carpentries and by volunteers who volunteer their time and expertise to create those lessons. And unfortunately, this particular one didn't cover NumPy or other graph of plotting libraries. But Anujad shared some really great resources if you like to try other plotting libraries. Great. So on this note, thank you very much for joining me for these days. I really hope that you've learned something and you enjoyed this workshop. This is aimed for people who don't really have any experience with Python, and we kind of teach the basics of it. So hopefully you can take over now and kind of start working on different projects. Please support open source software and share your knowledge. The Carpentries is a non-profit organization that kind of promotes good practice and scientific kind of basic scientific skills. My name is Danai Kore. I really want to thank very much Anujad, who was our helper today, and Dennis and Gina, who coordinated this. So thank you very, very much. I really hope I see you in the future in some other activities. Keep checking on other events. We offer so many kind of resources and so many workshops. So I really hope to see you. Thank you all very much. You were great. And yeah, hope to see you in the future. Thank you very much.